Okay, so we're on E equals I times R, right? All right. So now we go E, I, R. We have our circle. We don't know the resistance. We have a mystery resistance. So we basically are looking for what this resistor is, right? And we want to hook up something to do this. What are the two things that you need in order to make this work? In order to make a circuit out of this? Really only one thing.
The
Source.
voltmeter and the ohm meter.
Yeah, but what do you really need? I mean, how do you using Ohm's law, how do you look for an unknown resistance? What do you need?
Need power.
R is equal to E divided by I, right? What's what is the thing that you can what is the thing that you can control?
Power.
Yep. You need a battery. Once you have a battery, then you can use an ammeter and see what the current is, right?
Sounds right.
Are we in agreement there, Jim? Uh-oh, is Jim frozen?
Uh, I think Jim is muted.
Yeah, he
Yep.
was. Jim, does that make sense so far?
Yes, it does.
Okay. This is an ohm meter.
You need a current.
That is an ohm meter. An ohm meter is a combination of a power supply, DC a battery basically, and an ammeter. So,
Yeah.
okay, so you're testing something, and this ohm meter is putting a test voltage of known voltage because you also have a voltmeter on it. So it calculates voltage and it calculates current. So what does it do from calculating voltage and current? It calculates your resistance. It basically it puts a voltage on a circuit. It makes a circuit and it causes a current to flow. And then it sees how big the current was. Okay, so your question there on that exam question, what happens if you see this? So, Jim, what happens if you see that?
Um,
What's the very first thing that happens when you have an uncharged capacitor connected to a battery?
it's going to start to charge.
That's right. Okay. And it's going to start to charge very quickly, which means that there's a very big current, right? So E, I, R, put the E in the wrong place.
Then when
R
you
equals
discharge it,
R equals E. Yeah, but we're not talking about discharging it. We're talking about what happens when you put an ohm meter across a capacitor.
okay.
R equals E over I. At the beginning, the I is very, very large, right? Okay.
Yeah.
Practically infinity. So what's E divided by infinity?
Not defined.
No, it's very
So
defined.
large.
Yeah. What's one divided by a gazillion?
Oh, very small.
So it shows up as 0, right?
Yeah.
And then as it charges up, the capacitor becomes completely charged. And how much current do you have flowing? Because the capacitor is now at the same voltage as the battery.
None.
None. So your resistance then at the end is E divided by 0, which is infinity. If you were to plot this
That's
on a
infinity.
graph, plot this on a graph of resistance versus time, it would go like this.
Okay.
And
I didn't know.
Go ahead.
I didn't know about the amplitude supplied by the meter.
Mhm.
That changes the whole thing and makes
Right.
it.
Right. Essentially, it's a self-contained test circuit. So
Okay.
so now here's the other thing. Let's say that you're testing a circuit, right? You want to test this resistor, which is in a circuit, and it's got a battery hooked up to it. And you hook up a voltmeter, or sorry, not a voltmeter, but you hook up an ohm meter right here. What'll happen?
You'll measure the resistance of the resistor,
You will
the
not,
ohms.
because the resistor is already getting current from here. So it's already in a circuit, it's being tested, and your battery will be running extra voltage through your ohm meter. So what'll happen to your ohm meter?
Pop the fuse.
Yeah, you'll blow it up.
Okay. That's a
And,
question
yep,
on the test.
sure is. The other one is, let's say you have this circuit and you want to see what the current is, and you accidentally do this. I've done this before. Now you have a short circuit running through an ammeter, which is basically just a coil with a pointer attached to it. Right? It looks like this. And the more current it passes, the more it deflects. Well, now, what resistance do you have if you look around this circuit right here between the battery and your meter?
The current's going to go through the path of least resistance, so it's going
That's
to run through the amp.
Yeah, short
right through
circuit.
there, and then you let the smoke out. Anyone familiar with letting the smoke out of things?
Magic smoke.
The magic smoke that makes all electronics work. When you let the smoke out, it doesn't work anymore because all the smoke is now gone.
Yeah.
Yeah, you let all the smoke out. So, yeah, every electronic device is full of magic smoke. And once you let the smoke out, it stops working.
You got to be careful. Somebody's going to believe that.
I know. Well, you know. Okay, so before we get started today, we've got 4 hours today, and hopefully lots of questions. And who's got questions from yesterday? Because if we have outstanding questions from yesterday, we don't want to leave them hanging. And don't be shy. There's no such thing as a dumb question. You got nothing? Everybody's good.
I've got a question.
Yes.
I'm sorry, I had my audio off.
I had to cut out early last night because I'm in Saudi, so it's pretty late my time. But are we going to be doing like review, like questions by chance?
Define review. I mean,
Like question answer, you ask a question and we try to answer it.
not really.
Okay, just curious.
Thinking they're all kind of already review questions, right?
Yeah.
Or-
Yeah.
Yeah.
Everything we're talking about is kind of review.
I had test related questions.
Go for it.
One is, when this is over today, do we get something from you to take to a place and show that we've done this and they let us test, or do they just take our word?
I mean, the class is just a class. I mean, I'm just helping you out. You know, I mean, you can just walk into an exam session and say, I'm ready to take a test.
Okay, I didn't know how that worked. Okay.
Uh-huh. Yeah, this is just me putting something together to try to give you some background information. But I mean, I took 6 exams. I took 7 exams in the process of getting my license, and I took 1 class, and that was for my novice license. Other than that, it was me just grabbing a book and talking to people and studying.
I think with what you've done in the book you've gave, I think I've got a pretty good. I don't think I'm good enough to take that one right after this, but I think, within a week of just cramming a little more, I think feel pretty comfortable. I think I could take a test and pass.
Have you been practicing have you been trying some practice exams and stuff?
I just started last night. I didn't do too good, but I got like a 54. But I don't really view that as too bad as a first shot.
Yeah.
And it's off that app you suggested, which is a really good app.
And we haven't finished everything yet either. So
Yeah. I have a question for you. Taking the test, if you want to talk to other countries like in Europe and Asia and stuff like that, you have to get at least get your general, or is it extra?
You get your general. That gives you, take a look at the
The frequency.
frequency chart.
Yeah, I
When you,
For your
Yeah.
high frequency.
yeah. And
and I mean, there's some access to HF with a technician license. There's a lot more access to HF. There's like, with a general license, you have at least partial access to every band.
yeah, okay. Yesterday I got stuck in anything with math. It gets me a little screwed up. And we were doing decibels, and I kind of got in there a little bit late, but I kind of got a little jilted with that because it was 10 and 2. The decibels were 10 and 2, those numbers. And we were trying to look at the decibel loss in a line, and I kind of struggle with that. But I think it's once I get it, I would get it, but I was just struggling with that. That's all. And for what it's worth, but that's something I got to go over. That's anything like the math issue. Concepts I can get to some extent. It's not too hard for me, but it's kneeling to the math. It's going to be, to me, it's going to require a little more effort on my part, which is fine.
Well, I mean, the decibel thing is really, honestly, it just comes down to memorizing those two things. I mean, yeah, you can fund it. You can go through and understand the mathematics behind it, which is, the fact that it's logarithmic and, exponents, and that's not, there's nothing overly complicated about that. It's just a
Okay.
formula. But if you just memorize the fact that 3 dB is the half power point, 3 dB is 2 times, and 10 dB is 10 times, you can calculate, you can get very close to almost anything.
Okay.
Yeah, I was gonna say I retook the practice test again last night after a brief pause, dinner and everything, and I scored 100. So,
All
and
right.
I think I scored it because of the comprehensive stuff, because that was a struggle point for me too, was the decibels. And I looked at that again and the notes and everything, and it brought it home. So I think that helped a lot.
Good. That's good.
Good.
Good for you,
Scott,
man.
can you say that again? Can you say that one more time? 3 dB equals
You tell me. How many times?
2.
That's right. 10 dB is
I'm
10 times.
guessing
10 times.
10 is 10, but 3 is 2.
Yep. Just don't get them
Okay.
backwards.
So how is it that 3 dB is 2? That's the part.
Because it's logarithmic. If you look
So
at
meaning-
the log, this is where you grab your calculator
Uh,
and you go like this. You type in, eventually, you type in, if you've ever used that logarithm function, you type in 2 and then you hit log base 10 or just log, and it gives you 0.3 because 10 to the 0.3 power is 2.
all right. Okay. All right. See, this is the part I didn't know. I'm sorry.
Mhm.
That makes sense. Okay. I just was lacking that.
Yeah. So I mean, if you want to try it, that's where it comes from. And that's actually all that decibels are. If you have, okay, 8, and then you take log base 10 of 8, and that gives you, let's see, what would it be? About 7 or 0.7. And then the log function is 10 times that, so it's 7 dB approximately.
Okay.
So I mean, it literally just comes down to the math of it.
Gotcha.
That just comes down to the math, and that's why 2 is 3 and 10 is 10.
All right. Yeah. It's just, that's the part I got kind of like broadside a little bit because I didn't understand that. So,
Mhm.
all right.
I think in the test, there's really only 3 you have to remember.
And
correct?
there's really probably only one that you'd ever get,
Yeah.
because
Right.
here's the other thing about the exam. You're never going to get an entire exam of math questions unless you take the extra class exam.
Right.
Do they even change the numbers from what the examples show?
No. No, the question pool is published. I mean, what you see in the test questions is the exact question that you'll get.
Yeah, if you're really good on repetition and educating yourself that way, that's the way I am.
The way my wife did it.
The app is excellent because that's what I've been continually doing for the last 8 days, 9 days, and it's just brought it all home. So it rotates the questions, you know, from that pool, and yeah, you'll see probably the decibel one, the two factor is the most helpful for me because that's where I was struggling because the math didn't add up. So I was doing the exact same thing that you were doing, Michael, because I'm like,
Yeah,
wait a minute, I don't understand how you get from
I know.
two
Well,
two to
Two to
three.
three.
Yeah. Yeah, and the thing is, it's like I guess what you were saying about the repetition is fine, it passed the test, but then that gets you into the ballpark. But you still, if you want to learn things and be able to build,
You will
antennas and stuff
because
like that, you got to know this stuff.
yeah, but you will because as you continue to do that, at least for me, as you continue to do that, there's pieces that you get from each and every question that you can apply to the next question.
Yeah,
And so that teaches you, at least again, for me,
right.
that has helped me build on each and every time that I've done it because it's in here. I remember that material, but that's the way I used to learn, you know, old school repetition
Yeah, me
is
too.
the
Me
way I
too.
learned best.
Yeah, same here.
Scott, I have a test question. Am I
Okay.
muted? Can you hear me? Am I muted?
We can hear you.
Do they allow you to skip a question and go back? Is that allowed?
No.
I don't know that I can hear you
Yeah,
now.
we can't
Yeah.
we can't hear you now, Scott.
Did it again. There we go. Yeah, you can just go back and you can skip every question on the exam and go back and then, read through them and then go answer them. There's no
Good.
time limit. I mean, you can do it as many times as you want.
Great, thank you.
So, all right. So this is a practical question. All right. I'm gonna just draw something out and we're gonna work through it because I think this is going to have some use to us. Okay, so you have a radio, it's a handheld radio, and it's hooked up to a Yagi antenna. And this goes up through space to another Yagi antenna to another radio. Okay. All right, here's our problem. We're again trying to figure out whether or not we're going to get heard. So this radio has a sensitivity of minus 120 dB. And we'll call it dBm because it's with respect to a milliwatt, right? dB with respect to something. It's a 1 milliwatt transmitter. So we're going to start with dBm and we're going to say, okay, how many dBm? We're going to do a 1 watt transmitter. So how many times bigger is how many times bigger is 1 watt than 1/1000th of a watt? How many times? 1,000 times bigger.
1,000.
Okay. How many decibels is 1,000 times? This comes back to understanding the fundamentals of this. How do you make 1,000? By multiplying.
By 10.
10 times 10 times 10. And every time you multiply by 10, you get how many decibels of gain?
10.
So that's 10 plus 10 plus 10 is how many dB?
30.
30 dB. So your starting strength is 30 dBm because it's compared to 1,000th of a watt. So that's congratulations. You guys just did the first part of the problem. And this is real world calculations. This is the kind of stuff that you will actually be dealing with to try to understand whether or not something is going to work. Okay, so you have an antenna. We're going to say that it has 4 dB of gain. And you have a piece of cable which has minus 8 dB. Really lossy cable. we're going to put an antenna over here that's 10 dB of gain. And this is good cable. We're going to put minus 2 dB. Okay. So in order to get negative 120, what is this mystery value in there? So we're going to start at 0 all the way here at the bottom. We're just going to add and subtract. 0 plus, we're going to go out, up, and around. Somebody lead me through it. What do we add first?
30.
30.
30.
And then
Minus 8.
Minus 8.
Minus 8.
Plus 4.
Plus 4.
4. Plus 10.
Okay. Well, we have minus
Plus
question mark.
X.
Right.
Right. Okay. Plus 10.
Minus
We have a
plus-
10 dB gain. Okay.
Then minus 2.
Minus 2 is greater than or equal to, what's our target?
Negative
minus
120.
Okay. So let's do the math. So 30 minus 8 is 22, plus 4 is 26, plus 10 is 36, minus 2 is 34.
4.
So we have 34 minus question mark, greater than or equal to minus 120.
154.
Okay. Yep. So negative question mark is greater than or equal to negative 154. And then we flip the signs. So we get question mark is less than or equal to 154 dB of loss. In other words, we can withstand up to 154 decibels of path loss with this system we just built. What is 154 decibels? What is 150 decibels?
Oh.
And it's loss, right?
20.
0.0000000000001 times. That's how much of the power has to come out of that compared to how much goes in. In other words, we can withstand a significant amount of power loss and still have this thing work.
Is that expressed in the watts?
Hmm?
The number that you came up with, you got 104 dB a loss, but the number that when you broke that down, what is that?
Oh, that's just times.
It's what?
That's just times. In other words, that's because it's a ratio.
I have a question. Down on the bottom there, it says negative 120 dB. Is that the receiver that's negative one? I'm just that part right there.
In other words,
the reason why I'm asking that question, I see negative 120. I'm thinking, is that operating at a loss already? I guess
this is the sensitivity of the receiver. In other words, if the signal is less than that, we won't hear anything.
It's less than that. And that's already negative 120, not 120. It's just negative. That's what throws me off, the negative. It's like, I'm thinking it's
just negative. What does the negative mean?
Was it negative dB?
Yeah. What does a negative exponent mean? What's 10 to the negative 1?
Below 0? I mean, it's
not below 0.
0.
10 to the negative 1 is 1/10 by definition. 10 to the negative 3 is 1 over 1,000.
Oh.
And since logarithms are, dB come from logarithms. And we multiply by a factor of 10, what's 10 to the minus 12? 120, negative 120 dB, there's a factor of 10 in there. So it's actually 10 to the minus 12th, which is 0.00000000001.
12 zeros.
Yeah, 11 zeros and a 1. But and then it's compared to a milliwatt. Notice that little m. So it's actually 0.000 watts. In other words, that is the actual amount of power that has to be able to come down the antenna to make that receiver hear something.
Wow.
Look at that number.
Extremely small.
Right? Yeah, it's extremely small. That is what we gain by having solid state electronics and high amplification and all this cool stuff inside a piece of equipment.
Wow.
Now, but then again, which number looks more useful? Minus 120 dBm or this thing with all those zeros? That's why we do decibels. It's a shorthand. It's a very convenient shorthand.
And that's what I was going to ask you. Is it 154? Is negative 154 dB greater than negative 120? In other words, would that receiver hear the negative 154?
What did we do? Remember that negative 154 is just a loss.
That's
if we have a billion watts coming in over here, right? We'll have.
I see. That's a loss, and that's from A to B. It's a loss.
It's that, and that's the important thing to note. It's decibels. It's one thing compared to another. In other words, like if you put something in a pipe, this is what you get out the other end.
Like if it's a resistor, you have ohms. In this case, it's decibels.
Yeah. It's just a ratio of what goes in, what goes out to what comes in.
That's interesting. Wow.
So if, like, for instance, if you have an amplifier, right? Okay, so this is another box. We're going to have an amplifier. It's a goes into and goes out of. Right? If you have 1 watt going in and you have 600 watts coming out, that amplifier's got gain. It's doing a thing, right?
Yeah.
If you have 0.01 watt or 0.1 watts going in and it's linear, you'll have 60 watts coming out. It's got a 600 times gain, or approximately 10 to 2. So that's going to be about a 17 dB gain amplifier. And that is how you rate amplification. You rate it in decibels. The same thing as if you, let's say, have an antenna up here, right? That's receiving a signal. So here's your antenna. And okay, this is actually a really good example. What's our receiver sensitivity? Minus 120 dBm. Okay, that means that anything higher than minus 120 dBm, remembering that's a negative number, so negative 118, that gets a check mark. Negative 122 will not get heard. Agreed?
Yeah.
Okay,
Yes.
so we take our decibel meter, essentially we have a watt meter, and we see that the power coming into the antenna is minus 125 dBm. Our cable has a loss of minus 3 dBm. Is there anything we can do to this system to make it function properly?
I put an attenuator in there.
No, not an attenuator.
Amplifier.
Put an amplifier in it. Okay.
Oh, amplifier.
So an amplifier, let's say an amplifier has a sensitivity, because it still has to hear something to amplify it, of minus 120 dBm. Now, let's make it more sensitive.
Oh, 125, and then you have.
Let's make it minus 125. That's the sensitivity of the amplifier. And it has an amplification of 10 dB. Where would you put it?
If you use it as a preamp, if you can use it as a preamp, then you would put it just after the antenna before getting to the receiver, so that it pulls in more of the receive, right?
Right, because if you put it right here, you would be at minus 128, and it wouldn't work. You are just amplifying the noise, so that's not the place to put it. You would put it not down there. You would put it up here at the antenna, because the signal coming in is right at the level of sensitivity, which is fine. You add 10 decibels to it because it's an amplifier. So now your signal is minus 115. Your cable is minus 3 dB loss, which means that you're now at minus 118 dBm here, which is higher than your receiver sensitivity, and the system works. So placing an amplifier somewhere can sometimes help, but you have to figure out, you have to understand where. You have to understand why.
I'm getting screwed up because I'm looking at the 118 and look at the 120, and you said higher. And I thought
which is bigger? Which is bigger? Which is a bigger signal?
Minus 110 dB.
Not minus 110.
Minus 110, because what does it actually mean?
It's closer to 0.
Well, it's 10 to the minus 11th, and this one is 10 to the minus 12th. Which one is bigger? I'll do it like this, minus 10 dB. What does that mean?
Minus 10.
10 to the minus 1.
It has less zeros.
Yeah, it has less zeros. This is 0.1. This is 0.0000000000001. This is 0.0000000000001. This one has an extra 0.
For me, I find it easier
Which
to
is
visualize
smaller.
it with a number line, so that the closer you are to center, it's a larger number. The further away you are on the left, the smaller the number.
It is, but it's, yeah, but that's not exactly how it works, because the number that it's actually made from is always greater than 0. It's just that it's like this. It's logarithmic. It's this. It gets closer and closer and closer and never reaches it. Like you can have minus 300 dB, which is 10 to the minus 30 power, which is still greater than 0, but it's almost 0. That makes sense?
Yeah, it's unlearning certain things that I have in my head. That's all. I mean, I know what you're saying. It's how my brain works.
That's why we're doing this. All right, station setup and operating controls. Okay. By Ohm's law. Somebody tell me what Ohm's law is again.
E equals I times R.
Okay, E equals I times R. That's important because when you're using a piece of cable, it's a resistor, right? You don't usually think of a piece of copper as a resistor, but every piece of metal has resistance. Copper has resistance. So because it has resistance, how do you limit its resistance?
How do you limit its resistance? Limit its resistance? How do you
limit the resistance of a chunk of copper?
How do you limit it? By
thicker or bigger?
By making it either bigger or cutting it. I'm not
sure. By making it shorter or making it fatter or both.
Yeah.
So when we're connecting a battery to a piece of equipment that has a plus terminal and a negative terminal, right? We no longer have wire that has 0 resistance. It has, if you look at it, it has a cross section and it also has a length, right? So the bigger the cross section, the lower the resistance, because the electrons have more room to flow.
Right, that makes sense. Yeah.
The shorter the wire, the less things it has to encounter. So when you're hooking up a radio to a battery, you want those conductors to be short and fat. So then you have to make a choice, because at some point it will get really expensive, right? And you won't be able to afford it anymore. It also might be really heavy, right? So what happens in here if this is a resistor and it's carrying, let's say, 100 amps?
Heats up.
What's voltage? What's Ohm's law for that?
Well, it's E equals I
Always
times
back
R.
to Ohm's law, right? We know our current and we know our resistance. It might be 0.01 ohms. Okay, so what's our E?
So it's got
in
100
that?
times 0.1 ohms.
Yep.
100 amps.
1 volt. Okay, so you drop 1 volt in this chunk of wire. What if you also drop 1 volt in this chunk of wire? How much voltage are you now losing?
Volts.
2 volts. What if you have a 12-volt battery? How much
10 volts.
voltage is now available for the radio?
10 volts.
10 volts. Okay, so what if your radio really takes 11.5 volts at minimum to operate properly?
I'm gonna make it.
It doesn't work. This is called ohmic losses or ohmic loss, where you basically have a loss of voltage. This is voltage drop. And what's going to happen to that extra power? Where's it going to go?
Heat.
Heat. You're going to heat up your wires, and you're going to, in this particular case, probably not be able to run the equipment. Has anyone ever seen a starter cable in a car?
Yep.
What does it look like?
It's pretty thick. It's got a lot of current.
It's about the size of your thumb.
Yep.
Yeah, and that's because it's 12 volts at about 600 amps to start your car.
Yeah.
Hey Scott, I got a question.
Yeah.
I am getting confused on the Ohm's law thing, like when to apply it, how to do it properly. I know I just watched that, and I'm still like I'm also running through HRE Tech and doing questions, and it's saying like one of the questions, for example, is how much power is being used in a circuit when the applied voltage is 12 volts DC and the current is 2.5 amps?
30 watts.
Hi.
Is it 30 watts? Is that the answer?
Yes.
Okay.
But how? Can you show me again how to do that?
Well, there's 2 forms of Ohm's law.
Right. I'm getting confused on which one to use when.
If it uses power, it's this one.
Okay.
If it uses if you're not looking at power, it's this one.
Okay.
And
well, like for example, that one said you have 12 watt or 12 volts DC. That would be power.
Well, no, you keep going to the next one. It says you have 12 volts DC. And 2.5 amps. Okay. So obviously it's this one, because this one has 2 of the 3. Now they could also say, well, if it's 12 volts and 2.5 amps, what's the mystery resistor?
Okay.
You're right.
So, and then of course you can combine these. You can say P is equal to V squared over R. P is also equal to I squared R, which is a combination of those 2 formulas.
Okay.
And they're both very useful. But you can always derive them too. I mean, P is equal to IE and E equals IR, and you substitute the E right there, and then you have P is equal to I squared R.
Okay.
Okay. So let's see. All right. So these questions that you see right here, these are the exact same questions that you're actually going to see. I mean, and they're the same ones that will show up in the app. Same ones that'll show up. Exact same wording. The answers might be out of order, but it's the exact same wording. Appropriate power rating for a typical 50-watt output mobile FM transceiver. All right. So, all right. 3 aces. I don't know 3 aces name. I know 3 aces though, right?
3 aces?
Yeah.
I'm not sure what that means.
Okay. What's your name? Because it says 3 aces.
Oh, I knew what you meant by that. I'm sorry. I thought you were talking about the question.
It said Andy?
Aaron.
Aaron. Okay. Okay, there we go. I'm going to make it a little easier for me. Okay, so Aaron, we're going to draw this equation. We're going to draw this circuit right now, and you're going to work me through it.
Okay.
Okay, so what are they giving us? They're giving us a 50-watt transmitter, right? So what does that mean? What is 50 watts?
It's 50 watts.
What is watts?
It's power. It's a function of power.
Good. Okay, so now we got power, and they said our voltage is 13.8 volts DC. All right, so what are we missing?
Current.
Okay, which formula do we use?
Well, you could use the voltage squared divided by R.
Well, we could. I mean, we'd start with PIE. Let's start with that.
All right.
Okay. So what don't we know?
We don't know the current.
Right. So I is equal to P divided by E, which is 50 divided by 13.8, which is about 4 amps. Okay. So that is how much in theory it would take to run that. But now let's take a look at the actual answer in the book. Okay. Notice what the answer in the book actually is.
12 amps. It just gives you a definitive number, like.
Yep. Okay, so now the reason is
13.8 at 12 amps.
Right. Why is it 13.8 volts at 12 amps? Because notice 13.8 volts at 4 amps is also an answer. The question is, which is an appropriate power supply rating? So why is the answer, even though we just went through the calculation?
Because you're not going to get 50 watts because you won't get the power rating at 4 amps.
Sure you will. We just said that the 13.8 times 4 it's actually more than 50. So why not?
Well, appropriate, I guess.
Yeah. Why is it more appropriate?
Because it'll burn the transmitter up at 4 amps.
No. Remember, that's just current.
Because if you're running the 13.8 at 4 amps, you got to pop the fuse in the power supply.
No, yes, but why?
Because if you're just running if you're just doing the carrier, you should be fine. But when you're running modulation, you're gonna peak it.
Nope.
Because it may not have enough. It may not have enough power to. You're drawing more power from that power supply than it can handle.
The question is why?
Fluctuation?
Nope.
You're
power loss.
Underutilized. I mean,
what's the efficiency of a transmitter?
50%.
At best, 50%. Okay. So in order to put out 50 watts, how much do you actually need
100
to pull into
100 watts?
You need 100 watts in. For a 50-watt transmitter, you need at least 100 watts available. So if we go through and do that calculation again, we would find that it's 13.8 volts at about 7.5 amps at best. That's assuming 50% efficiency, but in reality, it's not even 50% efficiency. And so if you look at a transceiver, what else does it have? What do you see on it when you look at a radio? I'm going to bring up a picture of a radio.
Well, you've got your transmitting, which is going to require power.
Right.
Receiving is, no, it's not the case so much, but you're going to be drawing power from the transformer.
Right. But for what? Think
Go
about.
ahead,
well, when you're for what? I mean, when you're broadcast, I mean, when you're transmitting.
Right. But think about things that are actually happening.
You will have your LED display.
You have an LED display. Very good.
You'll have your meters.
Yep. See, look at that. We've got a display.
Oh, if you're at your peak power, you're not gonna be able to run the baseline components, I guess, maybe.
Is there a microprocessor in there?
Yes.
Yeah.
Yep. How about a backlight?
Yes.
How about speaker?
Yes.
Yeah,
Yes.
you've
All
got
require
that.
power.
All those things. I mean, you have amplifier circuits. You have an internal power supply that runs the display. You've got all kinds of stuff happening in there, which is why just a plain old transmitter is not just a plain old transmitter. There's, a radio has probably an amp or an amp and a half of current that goes into it just to run the baseline function.
I see.
So
Wow.
that's why the answer actually is 12 amps. That also gives you a little bit of room for any additional stuff that you might want to run.
Not stress the power amplifier if you had the lower 4 amp rating, would it not burn that up?
No.
I mean, considering you didn't say you had a 12 amp fuse in there and you tried to use that much power, would it not stress that power amplifier?
The power supply. It would stress the power supply, and it would either blow a fuse or it would crowbar or something.
Okay, that's what I
So
wanted.
yeah, but the transmitter would be fine. The transmitter itself would likely be fine.
Yes, I
So
agree.
the power supply would be upset.
Yes.
So the key word in that question is the rating.
Appropriate
rating, right? Because they are conservative on the ratings.
Yep. Yeah, it takes. So the other one is, okay, let's say you have a 100 watt HF rig. So notice this. They don't actually ask this one, but let's say you have a 100 watt HF transmitter. Just thinking about that, 100 watts at 13.8 volts is about 8 amps. A properly sized power supply for a 100 watt HF transmitter is at least 20 amps, and preferably 25, for the exact same reason that the efficiency is at best 50%, and in reality it's not even that. So a 100 watt radio takes closer to 250 or 300 watts to run it. So this starts to become a problem. Let's say that you have an amplifier that puts out 1,000 watts, and the efficiency is about 50%. So if it takes 1,000 watts out, but the efficiency is only 50%, that means you have to bring 2,000 watts into it, right? And so at that point, you're not looking at running it off of a DC power supply, because you'd be at 13.8 volts and 2,000 watts, you'd be pulling in 160 amps. So you're not doing that. You're running it at a much higher voltage to keep your cables from getting, really ridiculously thick and having to build a 160 amp power supply. And in a lot of cases, you're running it off of 120 volts plugged into the wall. And sometimes you're running it off of 240 volts plugged into the wall, which is why the concept of getting a sizable amplifier is the last thing that you're going to do, because it requires some different kinds of measures. Antennas are a lot cheaper.
I was just going to say that. I learned that yesterday.
Antennas are a lot cheaper.
Yeah, it makes sense now.
Yeah. All right. What signals are used in a computer to radio interface for digital mode? Well, digital is ones and zeros, and a computer puts out ones and zeros, and a radio takes in ones and zeros and converts them into tones or digital data that's modulated over the airwaves. So you have to know what the computer and radio are exchanging. So there's receive audio and transmit audio, two different directions, and a way to key the transmitter whenever the computer says time to transmit.
Oh.
So how are the transceiver audio input and output connected? Audio input and output of a computer running WSJTX. The key here is FT8. You have to know that FT8 is operated by WSJTX software. That's the key thing here. Which of the connections is made between a computer and a transceiver? Well, the computer line in has to be listening to what the transceiver is hearing. So the transceiver's speaker output, which you would normally be listening to, is now being listened to by the computer through the line in connector. Okay. Which of the following could you use to cure distorted audio by RF current on the shield of a microphone? Okay. This is really actually very important. Has anyone experienced a choke? Does anyone know what a choke is?
Yes.
No.
Okay. We got some yeses and some nos. Okay, good. All right. So we're going to do chokes. So when you build a transformer, what is the goal of a transformer? It's to convert one voltage to another one, right?
Yeah, through induction.
Right, through induction. So inductor, induction. So that's a coil. In order to constrain the magnetic field, you would basically take that coil and wrap it around a piece of iron. So or some other ferromagnetic material.
When you say constrained, what do you mean? Like, I mean, are you trying to?
It concentrates the magnetic field in that core.
Oh, I see. It doesn't like, okay.
The strength of the magnetic field in the core is extremely high.
Okay.
So there's some around the outside, but it gets essentially focused, and this makes a magnetic circuit going around and around. Now,
So if you didn't have that core, then the magnetic field would be bleeding over your circuitry, I guess.
It would be very weakly linked.
Oh.
So that transformer doesn't work very well anymore if that's the case.
Oh. Oh.
It has that core allows the magnetic field to be directed. The bulk of the magnetic field to be directed through the material by virtue of the fact that that core is largely iron. Iron is very magnetizable material. So it allows you to constrain it. There's other ones too. There's cobalt and there's nickel and things like that.
So like you're saying that the core, the choke, it constrain, is it?
We're not at the choke yet. We're not at the
or not choke, but that iron material is to focus that magnetic.
Focus the magnetic field and run it essentially as a loop inside.
Okay. All right. I'm catching up. Okay. Thank you.
Okay. So now, importantly, wire makes a magnetic field if it's carrying a current.
Correct.
What happens on the other side is that a magnetic field running through a wire makes a current and a voltage. Right? It induces, thus induction. Does anyone have an induction stove? Induction cooktop?
I don't, man.
Induction cooktop? Anyone?
No, I've seen them.
Yeah. But note when you get an induction cooktop, you have to use special, they work very well, by the way. You have to use a special pan that can couple to the magnetic field that's being generated by the induction cooktop. It has to be able to do that, or else it doesn't work. Like aluminum doesn't work. So what happens with a choke is that we choose a slightly different material rather than iron, such that if we have a piece of wire like this, it is important to think of this as actually having some thickness. And here's a cross section of the wire. And in some cases, it will be something running through the core and then something running through the shield. Right? But we're going to not ground the shield here. This is the outside. Oops.
Oh, it's a shielded cable?
Yeah.
Okay.
Okay. So so what we can do is we can actually put this through like a donut, such that this material is suppressing. This is actually not iron. It's typically an iron powder mixed with glue with some other metals in it. What happens is, as current flows through, what happens when it gets, this is current flowing always makes a magnetic field. Everyone agree with that?
Yes.
Okay. What happens when it gets to this material, which is like iron?
I don't know, it collapses maybe?
It constrains it,
Or constrains.
the magnetic field inside it. But this is a special material that's been picked so that any magnetic field that any magnetic field that gets constrained in here generates heat in the core. So it intentionally generates heat by taking the magnetic field and whipping it around the circuit, whipping it around that core. Well, if that happens, where does the energy go?
It dissipates in the air.
Dissipates as heat. So the current that made it is then knocked down. You're basically taking the power that the current was carrying and you're converting it into heat on purpose.
Oh, wow.
So why would you want to do that? So the question of why you would want to do that, let's not even say that this is a shield. Let's just say that it's a piece of wire. And you have a signal going in and you want, let's say, DC. And it turns out that you also have AC on this. There's no reason we can't have multiple voltages on a single wire. We could have this, and we could also have this. We could also have this. That's DC. This is our 0 point.
Wow.
Right? We can have multiple voltages on a single wire. Well, the way that I drew this up here, what voltages do you see there? Here's our circuit.
I see AC, I see solid DC, and then I see
a couple of frequencies of AC, right?
Yes.
Yeah. Okay. Well, if this is a DC power supply and that wire is picking up your transmitter, if it's picking up RF from your antenna, where is that power going to go? If
It's
you're
going to
trying
go
to power,
it's going to go through your conductor.
Yeah, if you're trying to power your computer,
you're going to get noise.
Yeah. Okay. So what'll happen to your computer?
It'll start glitching.
It'll start glitching and it might shut down. Yeah. So what happens is that you pick a material, which is a suppressing material, which is essentially tuned for a range of frequencies. It responds, for instance, to anything between 1 and 50 megahertz by constraining the material, by constraining the magnetic field and burning it off as heat. This is called a ferrite choke. It's a ferrite because it's based on iron, and it's a choke because it takes your RF signal and dissipates it as heat. So because it is essentially tuned for 1 to 50 megahertz in this case, which of these three signals up here at the left-hand side will be able to pass?
Well, for sure the DC.
That's right. So it will suppress both of the AC signals and permit only the DC to pass. Has anyone ever seen one of these on a piece of equipment they might have?
Yeah, I've seen them, and you know,
it looks like
they're
this.
on pretty. Yeah, they're pretty much every power supply.
It looks like that. That's why it's there. That's exactly why it's been placed there.
It's for the power supply, not to get noise on it.
That's so that whatever you're powering doesn't get noise, like the computer.
Oh, it's coming out of the power supply into the system, and I see what you're saying. Yeah.
And the other thing is that I actually have an RF suppression kit. I have like a box of RF chokes that if I get, let's say my computer starts to act funny, I look at my computer, it's got multiple USB cables coming out of it. It's got an HDMI cable coming out of it. It's got a power supply cable coming out of it, right? And one for the mouse and one for my radio sound card. So any piece of wire can function as what?
Antenna.
As an
All right.
Antenna.
You just got it. You just got the whole gist of this section. Any piece of wire can function as an antenna. Antennas can transmit, antennas can receive. They can conduct energy at different frequencies into electronic devices that never wanted to see them.
So I guess especially if you have a power supply where you've got or you got any kind of a system that has AC, DC, and signals going through it, it's important to you want to make sure that you're not getting any EMI on the
well the
DC.
key is that you've got RF floating around everywhere.
Sure.
Right? If you've got something that you need to be clean, like I have RF chokes on all of my USB cables, on my power cables, on my mouse cable, because the computer can pick up those signals from anywhere.
Now, Scott, I use a MFJ 915 choke on my line coming in on that 18-foot vertical.
Yep.
Just before my my 5 selector switch, and that helped with my that helped with noise level.
Common mode noise. Yes.
Yes.
Okay. So this brings up okay. So this brings up another thing that we're going to cover right now because it's actually really important. So we're going to draw a conductor, right? We're going to make it nice and fat. Here's our conductor. Can everybody see?
Yep.
Here's our single solid copper conductor. Okay. If I were to look at a DC current, DC flows uniformly throughout the current, throughout the cross section of the material. As I start to increase the frequency, that is no longer true.
Flows outside?
It flows proportionally, very little in the center, and more and more and more on the outside. And the higher the frequency goes, the higher the current distribution on the outside, to the point where the current on the inside basically goes away. So RF, which is a high frequency AC, flows on the outside of the conductor. And DC flows everywhere.
Oh, you're talking about what flows on the outside is AC. Okay, AC flows on the outside.
This is called the skin. This is called the skin effect.
Yeah, and that's for AC, right?
Yep, AC, and in particular on RF, it flows toward the outside. In fact, so much so, this is actually kind of trippy. We're going to draw a piece of coaxial cable. All right, here's our coaxial cable. Coaxial because it's on one axis. Okay, so we have a center conductor going through the middle. And then we have a shield right here. Actually, let's make it like a braid. Right, this is a braid going around the outside that's wound around the outside. And we have a spacer on the inside. In between them.
Oh, yeah.
Okay.
Silent.
How many electrical surfaces are there in this cable for RF?
2.
No, there are not 2.
It's just the one. It'd be the
Nope.
the shield.
Nope.
3.
There's 3. There's 1.
Center.
There's 2 on the inside and 3 on the outside.
Oh,
there
wow.
are actually 3 different places for RF to flow. 1 and 2 are typically matched with each other. And if you're and you were talking about using a choke, you can actually, where your cable comes into your house, for instance, you can actually put a choke on it. And what that does is that if the current that's flowing on the inside is unaffected, the current that's flowing on the outside will be cut down right here by the choke as the cable goes into the house, essentially ending the signal that's coming into the house right there. So what that really does is it only works on number 3. Number 3 can actually make a really big problem if you don't have a choke there. You can get RF noise getting into your house, into your equipment. So it can also be used in some specialized antennas as well.
Yeah, I found that I had to actually eliminate a lot of the LED bulbs that I had in my office and just use standard.
That's just RFI. Yeah, that's
Yeah.
because of the switching. They switch at a very high frequency and they make noise. So, you know, every time I try to move on to something, you guys bring up another really good point. Okay.
We just love it.
I know. Okay. So here's another thing. I got to erase this now. Okay. I'm going to draw a wave. All right. And I'm going to say this is a pure sine wave of 3 megahertz. If I look at this on the frequency chart, I would see at 3 megahertz, I would see an amplitude. Are there any other frequencies there? Nope, just the one. It's a pure sine wave. But now I'm going to take that sine wave and I'm going to make it messy. In fact, I'm going to make it so messy that it looks like this. It's still switching at a frequency of 3 megahertz. I am still going to see a spike at 3 megahertz, right? Unfortunately, I'm also going to see something at 6 and something at 9 and something at 12 and something at 15. And they're going to be smaller as it goes out. But they're going to tail off somewhere out way in the distance.
Really?
Anyone know what these are called? Integer multiples of a particular frequency are called harmonics. And the reason that those exist is because, believe it or not, Fourier showed, and also Laplace, that any waveform that you can draw is made up of a potentially infinite number of sine waves.
Infinite numbers.
Any waveform that you can draw is only made up of sine waves of different frequencies. Which means that if you have a pure sine wave, it only has one frequency. If you have something that is not a pure sine wave, for instance, a triangle wave, even though it has a frequency of 3 megahertz, it also has stuff in it that is then used to modify, first of all, a sine wave, because you start with a sine wave, but then you add other things that would alter it to make it look pointy. Fourier was an absolute genius.
So how does this translate in what is the net effect, I guess? Harmonic.
Okay, here's the net effect. What do most electronics do for turning things on and off?
They switch on and off.
What does your LED circuit do? What does the wave look like?
Square wave?
Square waves, right? It's electronics. They turn on and off.
0 and 5 volts.
Yeah, but the voltage doesn't matter. They go or they either go +5, -5, or sometimes they'll go to 0, like that. They're turning things on and off. They change the width of these to change the intensity of the lights. That's called pulse width modulation. But it's square waves. So what does square waves make?
You're saying that there's a series of sine waves that are affecting each other in such a way that we view them as square waves.
Yeah.
And that's the harmonics.
Yep. And in fact, then when you go to listen to your receiver and you have all kinds of interference on your radio, it's being generated by the switching of your LED circuits that are operating at high frequency and generating all these harmonics, which is why you felt like you had to turn them off, and then your noise went away, right? That's exactly why. Because
got rid of them.
That's right. Because the switching generated harmonics that you could add, that had enough energy at different frequencies that you could actually hear them as interference.
That's why some people like analog for music and stuff like that. Like
that's a personal thing.
Yeah, I know people have it. They're
But,
audiophiles.
All right. So does that make sense?
Yeah, it does.
Yes.
So it's
Okay.
so you were saying a pulse width modulation. Can you go back to the pulse width modulation? That's and what do we do with that? I mean, but you were talking about harmonics, and then you mentioned pulse width modulation.
Here. This is, let's say this is operating at 3 megahertz. This is also 3 megahertz. Which one of these has more energy in it? The top one or the bottom one?
The bottom one?
The bottom one. So
I am bigger width
because it has a greater duty cycle. It has more time during which energy is being delivered. Our eyes are not good enough to tell the difference between the flashing. So we just see it as the intensity of the light.
See.
That's PWM. That's how a lot of these circuits, when you have a dimmer on your LEDs, that's what it does. It changes the width of the signal being sent. So the frequency doesn't change, but the duty cycle does. All right, everybody ready for a 5-minute break?
Yeah.
Okay. All right, everybody back yet? Probably not.
I'm here.
Anyone with any questions?
I do have one question. I don't know if it's more of a math theory question or if it just applies to what we're covering, but why is volts and stuff not indicated with V? I noticed in the Ohm's law it's
E.
R, I, and E.
Yeah, it could be both. It's typically represented with the letter E because it stands for electromotive force. Now, more concerning is the fact that current is represented with the letter I.
Yeah, every practice test I've done, I've had to stop and look at my notes because I just can't. It's different than high school and it's throwing me off. Because I haven't done this since high school.
Isn't that cool? Yeah, you know, I get that a lot. I haven't seen this since high school. I get that a lot.
I mean, for me, high school was only 15 years ago, but you're surprised at how much stuff you forget in 15 years.
I've had people for whom high school was 60 years ago in this class before. They said, I haven't touched this since high school. Actually, there was one guy I had in class who said, I studied for my license and I never took it when I was 12 and I'm 70 now. And you know what was really cool? He passed the technician and he'd never studied for the general, and he went and passed the general too. And he said, what was really weird was that there was a question about neutralizing a tube amplifier and he remembered it. He remembered how to do it from when he studied when he was 12.
That's pretty amazing.
Cool.
That is cool.
That he hadn't thought about it in almost 60 years.
Is there still any usage for tubes anymore? Or is that that's done?
Well, I mean, let's go and think about power. Let's think about power amplifiers.
Take a look at the Astron.
Well, not Astron, but Ameritron.
Okay. And then
and
I have a
expert
vintage
linears
Yaesu
and-
101E, which is a hybrid,
right?
With the tubes in the back end and the solid state in the front.
Yep. So, but again, on the newer stuff, typically no. But let's think about this for a minute. If you have a kilowatt amplifier, right? You have to run it at some kind of significant voltage in order to get it to generate power at a reasonable current. Because, you know, ohmic loss in a wire is directly related to current. So if you have an amplifier that runs at 3,000 volts, right? To get 2,000 watts input power, you only need like 0.6 of an amp. So you typically run that off of, you know, 240 volt mains. You'd have a really high voltage transformer and you'd run a couple of power tubes. And they're far more forgiving than solid state.
Interesting.
So tubes
forgiving still, when you say forgiving, how so?
What's the output impedance of most equipment? How many ohms?
9 ohms or something like that? Or?
No,
I'm not sure.
What's the most common cable that we use? How many ohms?
50 ohms.
50 ohms. Most equipment is 50 ohms. You want a power main. Vacuum tube equipment is typically very, very forgiving when you have a mismatch in impedance.
Oh.
Solid state, not so much. Vacuum tubes, I mean, you know, if you're running it loafing along at 2,000 volts and it can handle 3,000 volts, a little bit of extra voltage isn't really going to hurt it.
Yeah.
But if you have a solid state amplifier that's running at 48 volts and it's really good up to like 52, and you get you get due to high SWR, you get some power coming back and it raises your voltage, and all of a sudden you blow up your expensive MOSFET amplifier.
Are tubes cleaner as far as power is concerned than
No.
solid state?
No.
Really?
No.
Okay, I was scared.
It depends. It just depends on whether it depends on the operating mode. They just like semiconductors, just like transistors, they have a cutoff and a saturation and a linear range. In that regard, they operate similarly. You can operate them in full on and full off mode, or you can operate them in a linear mode. In linear mode, a tube amplifier, actually, some people like them better. So
it's just preference then. Okay. Because I had a boss of mine, he was an electrical engineer and he was an audiophile.
That's different.
He loved tubes. He loved tubes.
Yeah, people say they sound warmer.
That's what he said.
You know what it really is though? You know what it really is? They glow in the dark.
Yep, I agree.
People like that. They glow in the dark.
I do. I think it's cool.
Yeah, they glow in the dark. All right, which of the following would you use to cure distorted audio? It's a ferrite choke. We just did that. Okay, so which of the following conductors is preferred for bonding? Bonding means connecting one component to another at RF with the intent of shielding and sending current to ground. And the answer is a flat copper strap. This comes back to the skin effect. So if you were to take a round conductor and you look at the surface area and then you take it and match it flat, which one has more surface area?
The flat one does.
Therefore, it has a lower resistance to the RF you're trying to send to ground.
Oh, really?
Yep. Flat strap.
Flat. I didn't know that. I mean,
flat strap. Okay, where should the negative return of a mobile transceiver be connected in a vehicle? The answer is at the 12-volt battery chassis ground. Now, if anyone works on their car, they know that the negative of a car, the ground of a car, is the entire frame. But how many amps will a 100-watt transmitter require?
100 watts.
Right? How many amps? I said, what's the appropriate power supply for a 100-watt transmitter?
200 watts.
It's about 20 to 25 amps. Okay, that's coming from your car battery. So, which do you trust more? A conductor that you actually picked out, or the frame of the car?
Frame of the car. Sure.
I don't trust the frame of the car at all.
Oh, you don't?
It's not designed to carry 25 amps of current.
Oh.
I don't know who built it. I don't know whether or not the robot that did the welding was on the job, sleeping on the job that day, or I have no idea. I have not a clue whether or not that circuit has been designed to carry that kind of current. So I don't want to risk it. I'm just going to run a big fat cable back to the battery. Have my own dedicated return line.
I fitted radios into patrol cars and always direct wired them to the battery.
Yep.
Never to the frame.
Never to the frame, because you can't trust it.
So what was that last part? Never the frame? What was that?
Never to the frame, only to the battery itself.
Oh, for your grounding, like an amplifier, what you just go right to the.
Or just the radio itself. The power comes directly from the battery and goes directly back to the battery.
Oh.
How can you determine the length of time the equipment can be powered from a battery? Batteries are measured in ampere hours or watt hours. So a 10 ampere hour battery would be able to provide 1 amp for 10 hours or 10 amps for 1 hour. So you look at how much how much current you're pulling, and you divide one by the other.
That is totally wrong. If you're using a lead acid battery, you can really only get about the top 50%.
Oh, that's true. That's true. Well, it depends it depends on your current draw. And
yeah,
if
it's very low, you can run the battery way down and kill the battery.
Well, but also when you say a lead acid battery, are you talking a deep cycle battery or a car battery?
I mostly work with deep cycle batteries, and they are very unhappy if they get discharged more than 50%.
Yeah, I'd agree with that. How could you? Okay, we did that one. Operating controls. Okay, so for this, we're going to do another share. Hopefully this works. And I'm going to make sure I share sound. And we're going to go to our web SVR. Has anyone played with the web SVR in the last day?
I did not know.
No? Okay. Just curious.
Did some roll this morning.
Okay. So I'm going to pull up a web SVR and hopefully we can listen to something and play with it a little bit. And let me pick 20 meters because usually there's something on 20. And look at that. There's something on 20.
Yeah, 5.9 plus Mark. Yeah,
Okay, so this section is about operating control.
Let's move up to 345. So we're not bothering Sunny. KOS wide at 14.345.
Okay, so notice we have our bandwidth.
Somebody's over here.
Here's the bandwidth of operating, bandwidth of the receiver. And now we're listening to nothing. This is called squelch. That's squelch. Squelch turns off the receiver when there's nothing to be heard. You notice you can adjust your squelch. So when is the time that you wouldn't, when you'd want to leave the squelch completely open like this?
When you're trying to pull in someone in the distance.
Yep, like a weak station.
Or to hear weak signals.
Yep, hear weak signal. Very good. Okay, so that's squelch. Okay, so if we're listening to a transmitted signal, let's go back to a signal like this one. We're going to refresh it.
To the Wisconsin Park, US 0601, QSL.
Okay, Larry,
I got you up and down. You're about a 5x1,
okay.
51, but I did
So,
copy your
notice
your
that
park and
this
the
audio
signal.
sounds very nice and clear,
Phoenix,
right?
Arizona here. Back
Yeah.
Okay, if you sound distorted, the reason for sounding, by the way, we're on page 76. One reason to sound distorted is if you're driving the microphone too much. It's the equivalent to basically me doing this and screaming into my microphone. Eventually, at some point, you will exceed the.
Still can't hear.
Sounds.
Can't hear you.
How about now?
Yep.
Okay. If you're using a an FM transceiver and you tune off frequency, it'll sound distorted. Quite clearly, if you are using a single sideband receiver and you're tuning off frequency, you'll hear like this.
You're 5'9" here.
Notice what happens if we're off frequency. Either Darth Vader or Mickey Mouse. Okay, so if you're off frequency, that will allow you to you tune it in, you make the person sound like a real person again. To enter a transceiver's operating frequency, right here, for instance, this would be essentially a transceiver. I can alter how this transceiver works by just punching in a number, 14268. A lot of systems will have a keypad for doing that.
20 meters.
They also have a tuning knob. So in this case, the tuning knob, there should be like a plus. Here we go. This is essentially a tuning knob. Most radios do have an actual knob to spin. That allows you to change the frequency. Notice it says VFO, variable frequency oscillator. This is what generates the radio's internal frequency.
Oh, okay.
How to enable quick access. Most radios today have a lot of memory channels. I'm sorry that the Yaesu that you have doesn't have any memory channels. My ICOM 7300 has, I believe, 1,000 memory channels. I only have about 10 of them programmed. My handheld radio has 1,000 memory channels. I've only got about 200 of those programmed. The scanning function allows you to tune through a range of frequencies to look for activity. Squelch, we just covered. It mutes the audio when there's no signal. How do you adjust the squelch so that you can hear a weak FM signal or any weak signal for that matter? And the answer is you tune it all the way off so you can hear all the weak signals. Okay, repeater offset. All right, so we're getting into repeaters a little bit. Before we draw the repeater, I'm gonna go and move over here. The advantage of having multiple receive bandwidth choices on a multi-mode transceiver is that we can alter what we're listening to. For instance, if I do this, and I want to eliminate a little bit of noise. Notice I can narrow it down a little bit. If there's offending noise, like a carrier or something nearby, that allows me to avoid some of the noise. That wide of a filter is not really appropriate for Morse code. Morse code, I can do this. What I do this for is to eliminate all the other signals that I don't want to listen to that are nearby.
Oh, wow.
Let's see.
Was that Morse code there? That beeping?
Yep. He's in Cleveland. See, I could open this wide up, and then I'd hear lots of other stuff. But notice,
how could you tell they were in Cleveland?
So I can copy code really, really fast, and then it's actually going really slow. So that's the purpose for having multiple receive bandwidths. So for Morse code, you typically go 500 hertz, sometimes a little narrower. For single sideband, you could go 2400 hertz, typically up to about 3000 hertz. Notice that we were sliding the receiver up and down to change the pitch. There's something called receiver incremental tuning, which allows you to just change the receiver frequency to make it more pleasant sounding without changing the transmit frequency. So that's RIT, or the clarifier.
Oh.
Push to talk, PTT, is what switches the transceiver to receive to transmit. And okay, so now we're going to go back to here. And we did squelch, and we did weak signal, repeaters, and DMR and stuff like that. Okay, so this is now getting into how a repeater works. A repeater is a device that has a simultaneous receiver and transmitter. Everything that it hears will be retransmitted. Typically, we put these on top of a hill because the higher up you are, we're typically dealing with VHF and UHF. That's usually line of sight. So the published frequency of a repeater will be its transmit frequency. So we're going to pick the one I'm a trustee of, 1.6.720 megahertz, which is in the 2 meter band. So anyone who is listening to that repeater will be listening on that frequency for the repeater to be transmitting. That repeater also has a published offset frequency. The offset frequency on the 2 meter band is 600 kilohertz, either plus or minus. In this case, it's negative 600 kilohertz, which means that the receiver on the repeater will be listening on 146.12 megahertz. So that means that when you key your handheld radio, it will change frequency from 146.72 to 146.12 when it transmits. This has to be programmed in. This is a programmable offset. And most repeaters will follow this rule. Some of them might have an odd offset. Most of them do not. The breakpoint is typically at 147. Anything above, it's a positive offset. Anything below is a negative offset. Usually. That's the convention that's usually followed. There's another something or other that's in repeaters, which is something called a CTC-SS, or private line if you're in Motorola talk. Actually, those little FRS handhelds and some of the GMRS radios will also do this. These are typically channels like 1 to 38. They call them sub-channels, but they're really not. What they are is, along with your transmitted signal, there is a sub-audible tone. This ranges between 67 and 254 hertz audio. If the receiver has been programmed, for instance, to listen for a tone of 100.0 hertz, and this signal that you are sending to it does not include that, the receiver will reject the signal and say, I heard it, but I'm not going to pass it on to the transmitter. And your signal will not be retransmitted. And that's called CTCSS. There's another one called DCS, which is digital code squelch, which is like a very, very slow, very slight frequency hopping scheme. And the sequence, if it's not matched, also will not allow your signal to be retransmitted. So that is basically how a repeater works. So so things that you can do wrong, you can be missing the CTCSS. You can have the frequency wrong. You can have no offset programmed or the wrong offset. These are ways to not get heard. You could be missing the DCS tone. All of these are actually published for all open repeaters. So this information is widely available. Okay. Moving on. Okay. Function performed with a transceiver and a digital mode hotspot. We do a lot of digital hybrid communication. We have this thing called the internet. We're using it right now. There's no reason why, if we have an internet that is functional, we can't actually use it for radio as well. So a transceiver and a digital mode hotspot, we connect our radio systems over the internet. There's a talk group on a digital repeater, which allows multiple people to use a repeater channel at the same time. So notice it's a digital repeater. It actually splits the time in two. So you have one group on the odds and the other group on the evens. And the repeater switches back and forth, and the radios all switch back and forth at the same sequence, and they're all synchronized. So you have a group ID or code along with the talk group. One interesting thing about this is that because it's a digital repeater, it's all ones and zeros, the repeater could be connected to the internet. Those signals could be sent to other places, and you could have 10 different repeaters all linked together over the internet with people that are all using synchronized radios. DMR is digital mobile radio. This is another form of digital communications with a handheld radio. DMR code plug might have 200,000 different repeaters programmed into it. Because if you have an access point, you connect your radio to an access point, you can utilize all of those different repeaters that are on the internet. On a digital voice transceiver, you enter the group's ID code. Once you've done that, you're on their repeater. There's something called a color code. Basically, that's sort of like a group. Color code is basically just another key that has to match the repeater in order to use the repeater.
Was that like MERS when they had I think
no,
MERS
that's blue dot, red dot, green dot. No, this is actually again part of the digital mobile radio system. It's just another criterion that has to be met. D-Star is an ICOM and Kenwood specific digital communication system. In order to use D-Star, you have to program your transceiver with your call sign because it sends a fair amount of information along with your voice. Okay, another thing that's important about that, because now we can move on. Another thing that's important about DMR handhelds, Yaesu Fusion, ICOM D-Star, Kenwood D-Star, is that they are completely incompatible with each other.
Wow.
So Betamax and VHS, if anyone remembers the Beta and VHS wars, these are competing technologies. You think the world wouldn't be big enough for three, but there are three. So each company, each group thinks theirs is best. All right, station equipment. A transceiver is a portmanteau of the words transmitter and receiver, thus transmitter, receiver. A transmitter converter moves RF input to a different band. It is a transmitter converter. Notice even convert is there. Transmitter converter. That's called a transverter. Why would anybody use a transverter? Because if you look at the frequencies that we have available to us, you see this band that says 1.25 meters?
Yep.
There's virtually no commercial equipment made for that band because it is not a ham band in Japan. And most commercially made handheld radios, mobile radios, they come from Japan. They're made in China, made in Japan, made in Singapore. And why would they make something that they're hardly going to sell any of? Because they can't sell them at home even. So there's very little equipment made for that band. 33 centimeters, there's very little equipment made for there. 23 centimeters, very little equipment made for there. So in order to get on one of those bands, what you would typically do is use a 10-meter radio as an intermediate frequency and run it into a transverter that moves your signal to one of these other bands. And there are many other bands above that as well that you can do the same thing with. A device that increases the transmitted output is known as an amplifier, and in particular, an RF power amplifier. Okay, so the function switch of an SSB CW FM switch on a power amplifier. Okay, so there is a reason for this. The reason being that you would think an amplifier is just an amplifier. An amplifier just makes a big copy of something. That's the whole point of an amplifier. So remember how an amplifier is built. It has a curve of input versus output, and it goes like this. Does everybody remember that I drew that yesterday?
Yeah.
Okay.
The linear.
Linear range.
Mm-hmm.
And this is the saturation range. And this is the cutoff range. Okay. Now, because most amplifiers are designed to be linear, we would operate them in this range. Well, in order to have a signal that goes back and forth, we would normally have this between here and here. So this input signal would have to be moved away from zero, which means that when there's no signal, this is our new 0 point, which means that we are wasting power. Always, even when there's no signal, we're still running the amplifier. So this is how single sideband works, because you want a clean representation of your voice. But now, when we transmit Morse code looks like this. It's just on and off. Can you think of a way to run this where we only care if something is on or off?
Just apply power for on.
Just apply power for on and let it run over here. And then when we're done, we turn it off. That is much more efficient. But if you tried transmitting single sideband sound with that, it would sound really, really bad. Your voice would be completely distorted. FM, similarly, looks like this. We're not changing the amplitude of FM. What are we changing? Just the frequency, which means that FM amplifiers can operate way up here.
Wow.
or way down here. They just need to be on. And it doesn't really matter if they get louder and quieter and louder and quieter, because when it gets to the receiver, it just gets trimmed anyway. So FM and CW are much more efficient amplification mode than single sideband. And that's why there are different settings on amplifiers. All right, here we go. This is one of my favorite parts of the class. Okay, I want everybody to unmute themselves. All right, so go ahead and unmute yourself. And on the count of 3, I want you to say your first name. Ready? So I'm going to say 1, 2, 3.
Michael.
Steve.
Okay, I heard a Steve. I heard a Michael. Right, but there was a lot of noise. Okay, the ability to pick one of those out is called selectivity. If you have a very selective receiver, my wife says I have selective hearing sometimes. If you have a very selective receiver, it means you can pick out just one thing very easily from a crowd of other people. Sensitivity means, for instance, okay, I'm going to say a number. Someone tell me if you hear it.
Nope.
What was it? What was the number?
I didn't hear it.
I couldn't hear it.
It was probably 7.
What was the number? Here it is again.
1.
Here it is again.
I could hear something, but barely make it out.
Okay. And that would be
16?
sensitivity. Yes, it was 16. So your system had higher sensitivity than everybody else's. That's
No, I'm just
sensitivity.
gonna lip read.
Yeah, that's sensitivity.
Or either that is better hearing.
Yeah. Yeah, exactly. Okay. Moving along. A preamplifier, we did this. We drew it where it should be. A preamplifier is always installed between the antenna and the receiver. Now, one of the things about picking the location for a preamplifier, sometimes it goes just outside of the receiver. Sometimes it goes all the way up at the antenna, depending on what you want to listen to. What's the problem with putting a high gain receiver out near the antenna?
High gain receiver out by the antenna.
Or I mean a high gain amplifier, a high gain preamp out near the antenna.
Weatherproofing?
Weatherproofing.
Water.
Yeah, exactly. It's got to be outside. It's also got to get power. So you have to run power to it, and it can be kind of a pain. But the other thing is that you also want to have RF switching so that when you're transmitting, it is muted so it doesn't blow it up. Okay. Well, a device that is used to convert a signal from one frequency to another is called a mixer. And once again, I'm going to share a web page, or sorry, share a whiteboard for this. All right. And you might ask, why are we spending time on mixers? Okay, so we're going to start with a signal at 28 megahertz. And I'm going to draw a device which has a big X in it. And this has 194 megahertz going into the other side. It has 2 inputs. Coming out of this is 222 megahertz. It adds the 2 together. Unfortunately, it also subtracts them. So it also makes 168. It also allows the frequencies themselves to come out. And it also makes multiplications. So 56 megahertz and 84 megahertz and multiplication of the other one. And it does subtraction of 1 to -2. And so basically there's a whole mess of different frequencies that are generated by this device. Again, this is known as a mixer. So we just we just talked about a piece of equipment that moves one frequency to another frequency. Remember what that was called?
Oh, yeah, you did say it. It's a
transverter.
That's a transverter.
Yeah,
a mixer is at the core of a transverter, and it works in both directions. Now, what we're looking at here is we're taking 28 megahertz, which is in the 10 meter band, and mixing it with a locally generated 194 megahertz signal, and we're adding them together to get that rare 222 megahertz piece of equipment. But what do you all notice about all those other frequencies? They exist, don't they?
Mm-hmm.
Yeah.
Which one are we aiming to get? Only 222, right? But we've also got one here at 168 and 194 and 84. And then we've also got 2 times 1. So we've got one at 388 and got one down here and another one here and another one here. This is the one we want. This is the golden frequency right there. We also have all these other ones though. And they're not necessarily small. In fact, this one is really big and this one is really big. How do we pick one frequency? How do we pick just one?
Oh gosh.
It would have to be a meter, right?
No.
Select.
How do you pick
A filter?
one
A
frequency?
filter?
Yep. Okay. And what are filters made of?
That's a good question. I don't know. Do I know this?
Tune circuit.
There it is. I just drew them.
Capacitors and
Capacitors
Oh
and
yeah,
inductors.
capacitors and coils. Okay, gotcha.
Okay.
Yeah.
So what happens is we're going to draw a circuit that looks like this. So what will this do? This will take AC and make it go that way, and take DC and make it go this way. Well, but that's only in the extreme. Remember, we can actually take those different components and we can line them up by doing an inductor and a capacitor. Remember we drew this yesterday? That was just yesterday, by the way. And we have 2 pi FL and 1 over 2 pi FC. Remember that whole thing?
Yeah.
And because this is positive and this is negative, we can make them so that they are equal and opposite. When they are equal and opposite, what does it appear that? They don't exist at all.
They cancel each other out.
They cancel each other out, and it just becomes a straight piece of wire for one particular frequency. Well, if we do it for one particular frequency and we choose it so it's 222, guess what we now have?
Band pass filter?
You have a band pass filter that looks like this. Just by using those two components. And you can cascade a bunch of them together and make it a better filter. You can also reject other frequencies by adding other components. But basically, the core of a tuned circuit is a bandpass filter that makes a particular frequency band able to pass through and rejects all the other ones. This is how we eliminate or reduce interference that's being generated by our equipment. This is how we get rid of frequencies that we don't want. Filtering, filtering, filtering. Now, we can also make these filters creatively. And we could make a filter that has a frequency response that looks like this. Where we have 0 frequency and infinity. Well, these are low frequencies. This would be called a low pass filter. We could also make one that does this. Those are high frequencies. That would be called a high pass filter. The one that does this, right in between, what would that be called again?
It's a notch.
No, it allows a certain range of frequencies to pass. That would be a band pass filter.
I'm sorry.
And I could also draw one that looked like this. And that would be called a notch because it looks like a notch has been taken out of it. So, and what are all of these made of?
Tuned circuits. Capacitor and
capacitor, inductor.
Inductor, rather.
Whether they are aligned in series or in parallel determines how they behave, whether they're band pass or band reject. But This is the core of everything tuned circuits, at least in the analog world. If you're talking about digital, it's a totally different thing, and you're not usually dealing with power. The other thing is that these components can be made very, very big and beefy, which means they can actually filter very high amounts of energy, very big signals, whereas digital stuff typically cannot. So this kind of thing is what is at the core of every decent receiver and transmitter that exists. And yes, there's no way around it. They're physical devices. And that's why we spent time yesterday on tuned circuits, because they are really that important. Okay, moving on. And by the way, if anyone has any questions, you should always ask. Well, the name of a circuit that generates a signal at a specific frequency is called an oscillator. It oscillates, makes a sine wave. It's a tuned circuit. The process of combining speech with an RF carrier signal is known as modulation. Okay, distortion. What can make distortion? If you overdrive, okay, radio frequency interference. If you have fundamental overload, your receiver is essentially swamped. It's overdriven. All of its ability to amplify something has been used up.
Spurious emissions.
Yeah, harmonics. What's a harmonic again? An integer multiple of a frequency.
Frequency.
Integer multiple of a frequency. So if I'm operating on 10 megahertz, what would the first harmonic be?
I don't know.
Integer multiple. That'd be 20.
20.
Next one.
20 and 1.
Or 40.
20, 30, 40, 50, because it's even and odd. This integer multiples of your fundamental frequency are harmonics. A spurious emission is a frequency that is not harmonically related, but still can be generated in an amplifier.
What I mean, what is that? Can you give an example of that? Like spurious emissions, like?
Sure. I mean, I've got you have a tube amplifier and it has 2 vacuum tubes.
Right.
There's a process called neutralization. Neutralization is supposed to allow you to match those 2 tubes together because they have slightly different characteristics. They also have capacitance because you have a space between 2 plates. They also have some inductance thrown in. Well, guess what? You have inductance and you have capacitance and you have an amplifier. You can feed back some of that energy back into the input side of the amplifier, and it comes out and goes back out and then comes back in and goes back out. And what's that called? If you have energy that goes out and is fed back into the input and gets bigger and bigger.
Oscillation?
That's oscillation. So what can happen is your amplifier circuit can go into self-oscillation if it's not neutralized. And what frequency will it operate at?
Shit.
Damn, hell if I know. That's part of the problem. That, yeah, basically your amplifier can go into self-oscillation. And when it does that, I don't know where it's going to go. Nobody does. And part of the problem there is that becomes a spurious emission on a frequency that you had never planned.
Oh, I see what you're saying. Okay.
So that's the kind of thing, a harmonic.
They could come from other external devices as well, or do you think? I mean,
typically not really. I mean, typically a spurious emission comes from a malfunctioning transmitter that is just generating a frequency unexpectedly.
Because I remember we were on a Navy ship out, and we were doing some testing, and we had a lot of course, transmitters and receivers all over the ship there. And the engineer mentioned there was some spurious interference or noises. So I'm wondering it was from other.
Well, okay, here's another thing. If you have a high-powered transmitter, some of a signal from somewhere else could actually be fed back into a transmitter and cause it to mix and create, essentially the transmitter becomes a mixer
I
and
understand.
it generates an additional frequency.
Oh, wow.
And I've actually seen that happen.
Right.
Are we talking about like cell phones next to a guitar amp?
No, that's not actually the signal from the cell phone getting into the amp. That's just the fact that the cell phone is spitting something out that is affecting the amp. But I've actually seen, okay, this is like I said, you guys are great at asking questions. So I'm going to bring up another one. This is a repeater. This is a real world thing that we had happen. When I was in college, we had a repeater that was operating on 145.49 megahertz with a receive frequency of 144.89 megahertz. And what would happen is that's a negative 600 kilohertz offset, right? Okay. So we would be transmitting a signal out into the world, and we would hear what sounded like broadcast AM radio, but it was like really distorted because it's AM. This is an FM signal. Okay, this is really weird. Well, we were listening and we thought we heard a little bit of a call sign. And what it turned out was we had our tower and we had our antennas. And here was the other antenna. We actually had separate antennas. This is our transmitting antenna. We had over here about 10 miles away, we had 980 AM. And over here, we had 1580 AM. What's the difference between 980 kilohertz and 1580 kilohertz?
Almost
600.
Yeah, almost. Yeah.
Okay. What's the difference? 600 kilohertz. What we had happening was that signal,
offset.
Well, those signals that were coming in, we had some rust spots on our tower. Rust spots basically made a point contact. This turned into a diode contact. A diode is a nonlinear device that can function as a mixer, a demodulator and a mixer. You've ever heard of somebody getting radio signals on their teeth?
Yes.
This is that. Essentially, we had this signal, which was on 145.49 megahertz, combining with this signal at 1580 and this signal at 980, all going into the tower, which was basically then sending out a signal on 144.89, which was the input to the repeater. And even when the person who was trying to use the repeater stopped using it, the repeater would completely lock up and just squeal.
Wow.
For 3 minutes until it timed out. And that was because it was receiving its own output combined with the mixing product, the difference of those two frequencies, and generating feedback and locking it up.
And you said rust spots on the antenna. I mean, it's little rust spots.
Rust.
Oh shit. Oh.
Yeah, we had rust, and it basically created a demodulation, or it caused a mixing of the signals.
Wow.
Yeah, that one took a while to figure out.
That's fascinating.
So, okay, so what should you do if your neighbor tells you that your station's transmissions are interfering with their radio or TV?
Happened to my friend.
Yeah. Okay. Well, we are covered by FCC Part 97. Ham radio is covered by Part 97. Part 97 is part of 47 Code of Federal Regulations that governs amateur radio. There are other services that are governed. Essentially, this is the FCC rules, right? There are Part 15, which governs all of those things that are not licensed. There's Part 90, which is commercial radio, Part 95, which is citizens band, and FRS. Part 90 is GMRS, and so on and so forth. All of these things have their own set of rules, and there exists kind of a hierarchy of who's at fault when something goes wrong. And Part 15, which is like your computer. Do you know your computer is a radio transmitter? Your TV is a radio receiver. So if a licensed service interferes with your unlicensed thing, it's the fault of the unlicensed thing. So if you're a licensed transmitter, the licensed transmitter always wins. And by the way, these are the FCC rules regarding amateur radio. You ready?
So basically, we can sick our dog on our neighbor. That's what you're saying.
Well, I mean, but then you'll have to pay for a dog bite. But notice these are the FCC rules regarding amateur radio. Essentially, thank God it's searchable.
So my friend who's him and his father did ham radio, and the neighbor who didn't get along with very much, just saying it interfered with their TV set, and so she called the FCC, and they said you'll have to report to the president of the ham club in that area, whatever.
That's right.
And it happened to be him.
Yep. Well,
So,
at
I
that
don't know how to
point,
resolve it.
now at that point, we really do try to make nice. You know,
Yeah.
so it's really their fault. You want to make sure that your own stuff is functioning properly and it doesn't cause interference in your own home.
Sure.
That's the first thing you do. But once that happens, it's somebody else's problem. Now, we pride ourselves on being ambassadors to radio, you know, ambassadors to technology. And if there's a problem, we'll try to help somebody out, but we're not required to. You know, we could tell them, look, I can't help you. You really just need to get rid of it and get another one.
Wow.
Here, I have this one at home. It doesn't get interfered with, and my antenna is a lot closer to my house than it is to yours.
Interesting.
Could you put a choke on the power input to the TV?
Actually, you could. Yeah. It used to be that telephones were a really big deal because wired telephones were wired into the house wiring for the phones, right? Any piece of wire functions as what?
Antenna.
There you go. And since the phone company owned the phone lines and you rented the phones from the phone company, they would come out and guess what they would install on your phone line?
Ferrets.
Ferrites or a capacitor. They would either they'd either install ferrites or an RF choke or a capacitor on your phone lines.
Well, plus that's why they had the wires are twisted pairs too.
But at a certain point, it doesn't help.
Okay.
If your neighbor's operating at a kilowatt, it's not going to help.
Right.
So they would come out and they'd put a filter on your phone line.
And that's another reason why they have a disclaimer on all electronic devices that it can receive RF transmissions.
Yeah. Take a look at, and sometimes you'll actually see on a piece of equipment, it'll say part 15 device. And there's this whole disclaimer about it has to accept all interference from other licensed things. So basically, basically if somebody is licensed nearby and keys up and your iPad decides that it's going to reboot, sorry. that's the rules.
Yeah, it's amazing. I've been paying a lot more attention on the labels on all the electronic devices as of late. And that part 15, as a matter of fact, one I noticed it, and it's a lot of this is bringing a lot of interesting things to realization.
Yeah, exactly. Part 15. Okay, the first step to resolve non-fiber optic cable TV interference. Note that it's non-fiber optic. That means that it's copper wire. The first thing to do is tighten all those connectors in the back of the TV because those tend to loosen up. If they loosen, you no longer have a shielded system. You have an exposed piece of wire, and an exposed piece of wire is a
antenna.
Antenna. That's right. So that is a way for signals to get out and other signals to get in. What could cause a broadcast AM or FM radio to receive an amateur station? Unable to reject strong signals outside of the band that it's listening to. So what do? If that happens, you block the amateur signal with a filter at the antenna input. Filter, 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 filter. Filter is the answer to almost everything. What can reduce overload of a VHF transceiver from a nearby FM station? Well, you want to block the FM radio station. I actually had an AM radio station that was really close to my house when I was a kid. It was WJOK, all comedy all the time, 1150. I actually really liked it. But they were a mile from my house at something like 10 kW. And it did not matter what radio I was listening to, I could hear them.
Oh, wow.
Well, they just overloaded whatever receiver I was listening to. I could always hear it. So if I wanted to block it, I would put in a filter that blocked AM stations. It's called a band reject filter. If something in your neighbor's home is causing harmful interference to your amateur station, work with your neighbor, inform your neighbor that the FCC rules prohibit it, and make sure your station is built properly. So, funny story. My neighbor, who I did not know at the time, I had interference on 3.523 megahertz. So 3.523 megahertz is right squarely in my favorite part of the 80 meter band, right down here. Morse code band, I used it all the time. Every so often I'd hear carrier signal. Sometimes there'd be an FM modulated voice on the carrier signal. And I'm like, that doesn't sound right. It's not identifying itself. So I grabbed a portable radio, battery powered, and I drove around the neighborhood. And I got to within what I thought was about a half a mile of where it might be, but I couldn't pinpoint it because all the streets are kind of windy and twisty and hills up here.
Yeah.
And so I gave up. About 6 months later, I tried again. And I got closer. And this time I went out with a portable radio that I was able to carry around. And eventually I gave up. It was getting to be winter, cold outside, didn't feel like doing it anymore. And then like a year later, I'm like, okay, I'm going to finally find this thing. And because I mean, the voice, it sounded like they were on a phone call. They were on phone calls and it sounded pretty personal. And it was broadcast, and I was hearing it on 80 meters. I'm like, this isn't right. So I walked around the neighborhood and I listened and I heard somebody give a name, and I told my wife. She said, I think I know who that might be. And I did a lookup on the neighborhood addresses, and I said, oh, I bet it's that house. And I walked around and that's where it was. And I said, but I can't prove it. So I asked my wife if she knew her, and she said, yeah. So she called her, and I was listening and I heard both of them talking.
Oh my gosh.
Yeah. So it turned out that what had happened was about 20 years prior, they had wanted to install a telephone in one of the guest rooms. And they bought this thing, which was called like, it was, I don't remember what it was, like a hopper or something like that, which used the power lines and,
oh, great.
And took the phone line and joined it to the power lines, and then used the power lines that ran through your house to send phone signals.
That's
so you'd plug it into the phone jack and it would separate the power from the phone signals.
I've actually got a set of those.
Yes. You need
Wasn't there a company called the Rabbit?
Yes, it was the Rabbit. That's it. And so what ended up happening was they were operating on 3.523 megahertz FM. And whenever she made a phone call, it would transmit her phone calls around the neighborhood on 80 meters. And
that's crazy.
And I told her and showed her, and she said, I don't want to be doing that. I'm like, no, you don't. She said, I'm going to disconnect that. Said, would you like them? I'm like, yes. So I gave them to a friend of mine who is our radio frequency interference guru for our area. He said, these are great. Thanks. So
yeah, so somebody has posted Magic Jack, and Magic Jack is actually voice over IP technology.
Yes. Well, that's fine though, because that's digital. Yeah. But this was analog.
Okay, I wasn't sure on that. That's why I asked.
Yeah, this was analog. It was basically taking an analog signal and modulating it, taking the signal and putting it on 3.5 megahertz and modulating that and sending it over the power lines in your house. Well,
yeah,
guess
I
what?
was listening to Art Bell, and he was talking about they want to try to put have the internet go through the high power lines, and he said would ruin the ham radio community.
Oh, yeah. But think about it. You're basically using all the wires, all the electrical lines in your house to send signals, conduct signals. Every piece of wire is a what?
antenna.
The antenna.
So they were using that and essentially they were broadcasting. That was broadcasting their phone calls using all the wiring in their house as a giant antenna.
Wow.
So I mean, and it covered a distance of miles. So yeah, you probably don't want to do that.
I guess what's the consequences of living next to a high tension like towers? The wires are way up there. They have a lot of voltage there. I mean, they're huge antennas, aren't they?
Yes, but they also have big transformers on them, and transformers act as chokes.
Okay, I'm just wondering.
But at the same time, you know what? We also, if a transformer decides that it's going to start acting funny and making noise, believe it or not, the power companies, they don't care until we tell them, because anytime a transformer is making noise, it's wasting energy.
Oh.
Energy can neither be created nor destroyed. So if it's arcing or something and making noise, they actually want to know. So.
Oh, I see.
Okay, what could be a problem if you receive a report that your audio signal through a repeater is distorted or unintelligible? You could be off frequency, you could be in a bad spot, you have a weak signal, your batteries are running down, it's all of the above. RF feedback in a transceiver or a transmitter, you'll basically have so, if an FM handheld is over deviating, that basically means that you're doing this and you're talking too loudly into it. Some radios, the modulation circuit can be set too high and they can over deviate. And what that causes it to do is spread further than the receiver's filtering is listening for. And because that entire package from the bottom to the top is basically what you sound like, that's the encoded version of your voice. If it spreads further and they're only listening to this much of it, they just lost a section of what makes your voice your voice. So you over deviate. The way to fix it is to pull the microphone away from your mouth, because most handheld radios, you don't have a microphone gain control on the radio. So you just have to learn to back away. Somebody will tell you if you need to. Test instruments and soldering. A multimeter. Multimeter is usually volts and ohms, sometimes amps as well. Electric potential. Electromotive force is voltage, so that would be measured with a voltmeter. Again, EMF, electromotive force. A voltmeter is connected in parallel with the circuit being tested, not in series. That will cause you to blow up your meter. Blow a fuse, done that. What can damage a multimeter? Attempting to measure voltage when using the resistance setting. Okay, so remember we were talking about what's inside an ohm meter? What's inside an ohm meter? Do you remember?
Potentiometer.
No. Remember, what's inside an ohm meter?
Battery.
A battery. Okay.
An amp.
A battery and an ammeter. Okay, so if you attempt to measure voltage when you have an ammeter hooked up, you'll fry your circuit. Done that. It's amazing how many things I've done wrong. Which of the following precautions should be taken when measuring high voltages with a voltmeter? Okay, so does anybody have access to Harbor Freight?
Yep, right down the street.
Does anyone love Harbor Freight for certain things?
Yep.
Yeah.
Yep. I admit
certain
it.
things. I like the word certain things.
Yes. Harbor Freight has certain purposes, right? Okay, so for instance, let's see, usually right on the front page, they will list this is not an ad for Harbor Freight, by the way.
Right.
Electrical, and we're going to go with multimeters. Let's see, where are the multimeters? Electric motors, electronics, generators, electrician's tools. One of these will probably be a multimeter somewhere. Okay, there we go. Plugs, terminals, connectors, multimeters. Okay. No, notice you can get a multimeter for the low price of $6.99. Right? I have several of these. I throw one in my bag. This is
sometimes free with a coupon.
Sometimes free with a coupon. That's right. And notice it's a digital multimeter. It's relatively accurate, actually. They work pretty well. But notice on here, they also have a setting. Let me see if I can get in there close. They also have a setting for AC 250 volts, DC 250 volts. Personally, I would not try to measure using these leads. Might be okay. I would not try to measure a 250 volt circuit with this meter. 24 volts, yeah. 120 volts, maybe. But if I was taking, if I was taking my life into my own hands, I probably would not want to do it. Because now, this is what I have at work.
Just make sure you get a set of Harbor Freight gloves to go with it.
That's right. Yeah. So this is what I have. This is what I have at work. And notice the price compared to $6.99. It's $476. But this meter is rated, you'll see down there at the bottom, 1,000 volts. And it truly is rated for 1,000 volts. So if you put your gloves on, the leads that you get with the meter, the lead kit, all of those are going to be rated for 1,000 volts. They have staked their reputation on the fact that they make good stuff, and that when you hook up 1,000 volts to this meter, it will not blow up in your hand.
And you can get these typically calibrated as well.
Oh yeah, they're test equipment, but that's why it's important to. That's why it's important to know what it is that you're using before you use it. And like they say, when checking high voltages, make sure that the meter and leads are really rated for the voltages. An ohm meter connected to a component to measure resistance is measured in parallel. Let's see. When measuring
the question you had before about with the meter checking the voltage, you check it. You're checking a component in parallel, but you said if you check it in series, you could blow it up.
Yes.
I don't see how do you check something in series like that? I mean, if it's a resistor, you put both leads on opposite sides of the resistor.
You never would.
Yeah, it doesn't. Yeah,
but just what can happen is, let me clear this. So you have a resistor, right? And the resistor is hooked up to a battery. And then you put your ohm meter across it. And this has a battery in it. And this also has an ammeter. So what will happen is, if you try to test it like that, this power source will basically go like this and go right through your ammeter. And since it's not the one that you predicted would be there, it's a different one, you'll damage your meter. That's also why when you're taking a measurement of a resistor, which is in a circuit, you typically will take this, which is soldered down, and you'll lift the lead so that it goes like this. And then you'll test this to there.
Oh, I see. Okay.
So here's your
float the lead.
Yeah, you would basically lift it off the solder pad.
I understand.
To test it. Okay, stop sharing. Here we go. Okay, let's see. What do you get? Hey, look, it's T7D10. What do you get when you see a large discharge capacitor and you hook up a meter to it? You start, because the current flow is initially very high. That looks like a short circuit. When it charges up, the current will be very low. So your apparent resistance starts at 0 and goes all the way to infinity. So a large capacitor that charges up, like in a power supply, will it'll look like you're hooked up to a resistor that's changing over time.
This is the question that I kept getting stuck on my when I was taking the tests, and it was trending as a miss because I had confused the definition of a capacitor, and I had to go back. So I know this one really well now.
And Jim and I, that was what we were doing before class. What's used to measure electric current is an ammeter. When used to measure current, an ammeter, unless it's an induction ammeter, which we're not talking about here, is put in series with the device, which unfortunately means you have to turn off the circuit and break the circuit and insert it into the circuit. You never use acid core solder ever. That's for like plumbing. A cold tin lead solder joint looks like a rough or lumpy surface. It should be nice and shiny and smooth. Okay, FM. A station that simultaneously retransmits a signal is called a repeater. There are a couple of different things that can repeat signals. One is a repeater. One is an auxiliary station, which is like a forwarding system, which receives something with the intent of sending it along to somewhere else. And there's a space station. A space station is anything 50 kilometers up or higher. So that means it's in orbit, basically. Or it could be a very, very high altitude balloon. A linked repeater network. We have one of those in Oregon where we have 53, I think, repeaters connected together so that any one of them, if they receive a signal, send the signal out and retransmit it to all of them. That's a linked system. On the 2-meter band, the common frequency offset for repeaters is 600 kilohertz, either plus or minus, depending on where it is. On the 70 centimeter band, it's plus or minus 5 megahertz. Those are just memorization things. We covered this one. CTCSS is a subaudible tone transmitted with your voice. If you can hear somebody, but the repeater can't hear them, a couple of possibilities. Improper offset, it's going the wrong direction or it's the wrong amount. You have the wrong tone or you have the wrong DCS code. DCS is that little frequency hopping thing. Okay, transceiver reverse function. That allows you to, instead of listening to the repeater, it allows you to listen to the input frequency on the repeater. Most handheld radios, for instance, have a reverse function. What that allows you to do is if, let's say, there's interference, you can say, okay, I'm going to go listen on the input and see if I can figure out where it's coming from. Nope, I don't hear anything here. If you have 50 people doing that, maybe somebody figures out where the noise is coming from. It could also be used to say that, oh, you know what? I'm really close to you, even though the repeater can't hear you. Let's talk simplex. Let's not use the repeater at all. What could cause an FM transmission to be distorted on voice peaks? You're over deviating. If you're over deviating, it's because you're talking too loud. So what's the way to fix talking too loud? Either quiet down or
away from the mic.
Back away from the mic.
Away from the mic.
Back away from the mic. Okay. Does anyone here have a license already?
I have GMRS.
No, ham license. Anyone else? Anyone
No.
here have a ham license already?
No. Nope.
No
I
one.
had an advanced license, but it expired.
By the way, do you know if you pass your technician class license and you can prove you had an advanced license, you get it back?
Oh, wow.
What's that?
If you pass your technician class license,
Yes.
your technician exam, and you can
Yeah.
prove that you had your advanced class license, you get it back.
Oh, really?
Yeah, really.
That's cool.
Yeah.
How do you? What's the definition of proving it?
Do you have a copy of it?
I may.
Do you have Do you have a page from like an FCC call book with your name and address?
I think so.
If you had proof of where you lived and your name, and you bring that to the exam, they'll typically include that with your application. You get your own privileges back.
Nice.
Oh, darn, that's really something.
Yep. Okay. Let's see. So, what was your call sign?
WD6GKX.
Okay, so I would say WD6GKX. This is N7JI. That's how you'd call somebody.
Yeah.
All right. If I was just listening on a repeater, I'd say this is N7JI monitoring or N7JI listening. Transmitting on the same frequency is known as simplex, two stations talking back and forth. Why do we have simplex frequencies? Because if we're a half a mile apart, there's no reason to use a repeater. There's no reason to tie it up unless we're trying to engage other people. There is a simplex calling frequency that we have. I believe it's actually on here. 146. Maybe it is, and maybe it's not. Nope, doesn't appear to be. 146.52 is our national simplex calling frequency on the 2-meter band. You just got to memorize that. And almost anywhere you go, if somebody has a radio on and it's scanning, they've programmed that frequency in. Okay, CQ means I'm calling anybody. That's what CQ is. Now, you would typically never say CQ over a repeater. It's just sort of convention, because a repeater, you expect there to be a machine there that's listening to you. But if you're calling out into the ether, looking for somebody to talk to, you would say CQ. That means I'm looking for somebody. Okay, before doing that, make sure you're allowed to be transmitting there. Ask if the frequency is in use. Listen to make sure that no one's there. The high frequency bands is where we usually end up calling CQ. And because of the way propagation works, it is sometimes the case that you will hear only one side of a conversation. So a frequency will be in use, but you don't know it. So if you don't ask, you might be coming down right on top of somebody.
Oh.
And hopefully they will tell you and you can go somewhere else. So how do you respond to a station calling CQ? Hey, let's see, where'd he go? I was going to say, give a quick CQ.
Oh, here he comes, coming back.
Yes.
Give a quick CQ.
CQ, that's WD6GKX.
WD6GKX, this is N7JI. That's it. That's how you respond. Just tell them who you are. The other person's call sign always goes first. Okay, always important to identify your station, even when you're doing on-air test transmission. So you think, okay, I'm just going to test this repeater. You just go, it's called kerchunking, where you just send a quick signal and see if you hear the repeater respond. Kerchunking, even though it's very, very short, for instance, I can do a kerchunk right here. Ready? Here comes the kerchunk. Can everybody hear this?
Nope, didn't hear anything.
Anyone hear that?
Nope.
It's Zoom. It's supposed to listen for a voice, and you're not putting a voice
here,
through
how
it.
about now? How about now?
Yeah,
Yep,
just
Okay, there was the beep. Okay, this is called kerchunking.
Huh.
I just key the repeater to hear the signal back, right? But that's a test transmission, which means at the end of that, N7JI, you have to identify. Always have to identify a signal that's sent out over the airwaves, even if it's really, really short. Okay, next. Okay, QRM. QRM is man-made noise. That means somebody is interfering with my signal. QRN is natural noise, like lightning or static crashes. But QRM is the one that you'll get on this exam. QSY means I'm changing frequency, right? And we even though these are Q codes, we usually send them in Morse code. QSY we use on voice also. QSY up 3. It means up 3 kilohertz. A band plan is a voluntary guideline for using different modes or activities within an amateur band. So let's take a look at this band, for instance, and we'll look at the 6-meter band. The fact that we have free reign. Notice that any licensee can use anywhere on the entire 6-meter band. There is nothing saying in the FCC rules, with this little one exception down here, this little red zone, that any frequency has to be used for any one thing. The fact that these are separated out into different functions, notice this says weak signal, no FM, the little green area. Digital is the yellow. Pink is FM simplex. Orange is FM repeater. Notice that these are actually spread out, right? We actually separate these out by color. That's a voluntary band plan beyond what the FCC says we should do. And the reason we do that is to make sure that people don't interfere with each other, to sort of keep the peace. So there is also something called a frequency coordinator. Notice we have this, I hope everybody can see that. Published coordinations. These are all the repeaters in the state of Oregon that exist and are assigned frequencies so they don't interfere with each other. This is how our 2-meter band is set up in our state. A volunteer.
You want to?
Can't hear you now.
Oh man, I did it again. These are a bunch of people in the Oregon Region Relay Council, and every section has one, every state has one, that get together and essentially volunteer to kind of like set something up to keep the peace, so that the frequencies can be frequency use can be optimized, and they're not people climbing on top of each other with different operational modes. So
Quick
that's called
question.
a frequency coordinator. Go ahead.
So at this point in the history of ham, obviously the internet has taken over pretty much all the value of this. How many people are left? Because everything I see on the internet is complaints back and forth by the longtime hand saying there's no one left.
That's bull. So let me ask here's the associated question. There was something called a telephone. Right? So the telephone came into existence in about, practically speaking, in the 1920s, 1930s. Did the telephone kill amateur radio?
No.
No, it did not. Okay, so did the creation of the internet kill amateur radio?
No.
No, it still exists. Did the creation of cell phones kill amateur radio?
No.
How about satellite comms?
No.
No, and in fact, one of the reasons is that we have continually evolved. Amateur radio has continually evolved and integrated other components of technology to make us a more viable and interesting service. Now, I personally still love getting on the HF bands and sending out a signal and seeing where the signal will end up. That
cool.
used to be all that amateur radio was. Back in the 1950s, at the beginning of the 50s, that's all amateur radio was. You could use that to make a phone patch, right? Vietnam, there were thousands of phone patches made over amateur radio from Vietnam to the West Coast where people could talk to their loved ones, right? Well, clearly that's not really necessary anymore. But think about all the technologies that are being covered on this exam. All these digital modes, all of the, all the computer integration. 40 years ago, there were no computers at home, right? So,
it's true. Yeah, you're right.
So what's interesting is that in the United States right now, there are about 760,000 licensed hams, which is actually the most there have ever been.
How many licenses?
760,000.
Wow.
Now, that is not to say that, the average age is not going up. The average age is going up. But that doesn't also mean that, kids, the same kids who found this interesting in the 1950s, in the 1970s, and the 1980s, that's who I was. That's why I still do it. I found this stuff fascinating, and I still do. Those people still exist.
Is that number counted the same way as they count votes in Chicago?
Well, I don't know. I mean, dead people get 5 votes each, right?
True.
What country do you think has? I mean, is the United States leading as far as ham radio?
Second, Japan is number 1.
Oh, really? I
Yep.
wonder why that is.
They've always been. Actually, in the beginning, it was the United States, then Japan, and now Japan has a little over 1 million hams.
Oh, wow.
Is it because of the manufacturing?
I think that's part of it, but I think the manufacturing is because of all the technology that a lot
I
of people.
wonder who number 3 and 4 is.
Germany is up there, and I don't know who number 4 would be.
On 38
Probably
lower
the UK.
sideband, I hear a lot of UK.
Probably the UK or Italy. UK or Italy. Okay, so a band plan is set up by a group of volunteers. Who picks those people? That's actually all the hams who are eligible to have repeaters. When 2 stations are on the same frequency, it is important to remember that nobody owns a frequency. They should work it out. Okay, Amateur Radio Emergency Service, or ARES, is a group of hams using ham radio equipment and their qualifications for communications duty in the public service. This is very similar to RACES. This is actually a civil emergency services group. So ARES is emergency services. RACES is civil emergency services, which means that you have to register with your local government. ARES does not. RACES does. They basically serve the same function. The other thing is that RACES, because you have to register with your government agency, is actually mentioned in Part 97 of the ham radio rules. Okay, sometimes we will set up nets. A net is short for a network. There's a group that I belong to called the American Radio Relay League, or ARRL, which you've possibly heard of. It represents about 160,000 hams in the United States. It's the one that gets out in front of Congress. If you get licensed, I strongly recommend joining. That's my blurb for the ARRL. They're our biggest advocate in front of government. And since government, they're the ones who ultimately give us access to these frequencies that we use. And by the way, how much do we pay to access these frequencies?
Nothing.
We pay nothing, which is a pretty good price. Now, if we took a look at some of these frequencies, how much would some companies pay and do pay to access the frequencies they use? It is in
millions,
billions of dollars. Yeah. So what we have is something that costs us nothing to use, and what we are supposed to give back is we're supposed to give back this. Let me find it. Here we go. I'm going to share it now. This is this is essentially our agreement that allows us to do this stuff. Here we go. Basis and purpose. And everyone just take a quick second and take a look. Hopefully you can see what that says. This is the agreement that allows us to do what we do and have these frequencies for free. So goodwill ambassadors, technology, electronics experts, we continue to contribute to the advancement of the radio art, and yes, it is an art, and yes, it is still advancing. There's still all kinds of new improvements being made. Radio is ubiquitous, and we provide service to the public as a voluntary, non-commercial service, especially with respect to emergency communications. So all these things that we do is the way we pay back everybody for letting us use these frequencies. So it's our job, once we get our licenses, to remember that and actually use them accordingly, use them appropriately. So one of the things that we sometimes do is we set up a network or a net. A net is essentially set up to transfer information from person to person. It could be something as simple as, hey, I'm just checking in, making sure that I can hear you, making sure you can hear me. Or in case of an emergency, it could be that the net is set up to transfer individual data about, things that are needed at an evacuation site, things like that. The person who runs the net station or the net is net control. Net control calls it to order and directs communications, essentially the traffic cop. When you participate in a net, you typically don't say anything unless you are asked to talk, unless you're reporting an emergency. Traffic is messages, official messages being sent back and forth across a net. Good traffic handling, that means you don't make any mistakes. You don't leave out a word like not. Now, the other thing, in order to make sure that that doesn't happen, is we add, for instance, a number of words that's called the check on a message. And if it doesn't match, that means we did leave out a word. So at that point, you'd say, okay, I obviously missed something. Tell me again. We also use these things called phonetics: Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, etc., etc. From the ITU phonetic alphabet. The reason we do that is because I'm going to pick Michael. Is it Razzi?
Yes.
Razzi. Romeo Alpha Zulu Zulu India, because it could be that somebody might not be able to spell it properly. And if spelling was important, we're exchanging official information, we'd want to spell your name right and make sure that it was. So we use phonetics. The preamble says, okay, how do I get this message from point to point? The check in a radiogram header. A radiogram is our official message format. The check is the number of words or word equivalents that we send. So I am going to the zoo. I am going to the zoo. That would be 6. So that's the message. I am going to the zoo. Check 6. If somebody only got 5, they'd say, okay, I missed something. And they'd say, all right, send it again.
Wow.
I didn't match. Now, a lot of stuff that we send is also done digitally. We have something called WinLink. WinLink is a radio email system, which uses a hybrid radio and the internet as a hybrid system to send email. And that's actually used quite extensively for emergency communications. When do FCC rules not apply? The answer is they always apply. It's a trick question. When are we allowed to operate outside the frequency privileges of your operating class? The answer is if I have a technician license and I see that somebody is about to get run over by, let's say, we'll say that a dam is about to break. And the only way I have to get information out about the dam being about to break is over the radio, but there's only somebody on a band that's like on HF that's an extra class operator in an extra class band, and my phone isn't working there and I have no other means. You do whatever is necessary. So notice this: immediate safety of human life or protection of property. That will come up all the time. That phrase will always be there. Immediate safety of human life or protection of property. If that's in the answer, it's probably correct. Who can contact the International Space Station on the VHF bands? Well, you look at the VHF bands. If you have privileges and can transmit, you're allowed to do it. So, technician class or higher license. Operating a satellite operating UV, UHF, VHF. Uplink is UHF. What's the range on UHF, everybody? Come on, let's see your memorization. How many megahertz?
300 to 3000.
Yep, okay, and VHF?
30 to 300.
Yep. Okay, so that would be 70 centimeters up, which is 420 to 450. That's UHF. And 2 meters down, 144 to 148. So that would be mode UV for a satellite. Modes that are often used by satellites, it's actually not only FM, it's Morse code, it's data, packet, it's single sideband. There are single sideband satellites floating up there. So who's able to launch a satellite?
Who's able to launch?
Yeah. Who's able to launch an amateur satellite?
An amateur
if you got
government agency?
If you have,
anybody who's capable of it.
If you have
Elon
a
Musk does
ride,
it.
if you have a ride, you can put up a satellite.
Oh, that's it?
Pretty much. It has to be coordinated. You don't want to end up walking all over another satellite. But if you can build a satellite and you want to put it up, there's a group called AMSAT.
Oh.
You muted yourself again.
I got to move this thing. So
I think that would be a culmination of between the FCC and the FAA or something like that, because it's going up and interesting.
So AMSAT is the Amateur Satellite Corporation, and they're the ones that coordinate, at least in the United States, amateur satellites. There are hundreds of satellites up there right now for that are just amateur satellites.
Get buddy with Elon Musk.
No, these are, well, yeah, you could probably get a ride up there.
Well, some might say it's just a lot more space debris too, as well.
Yeah. So here's AMSAT. So if you're into satellites and you want to build a satellite, you want to try to get a ride,
I never thought of that.
You can join AMSAT.
I never thought to do something like that.
So notice we also have arrl.org. This is the United States National Society for Amateur Radio. I'm a strong proponent of it. I recommend joining it. I can't make anyone do anything, but I strongly recommend, as they're our advocate in front of Congress and the FCC. You get your license. You want to protect the frequencies. You join ARRL. The money, some of the money goes to legislation and work on Capitol Hill. Okay. Impact.
Scott?
Yes.
It's Bill in Chicago. And I just wanted to, I'll be getting off soon. So I wanted to, first of all, thank you for the fantastic job you've done. It's been excellent and a very rich experience for me. But going back to your point about the 750,000 hams and the excitement of the hobby, and I'm sure you can tell 24 stories similar to the one I'm about to tell, and it'll only take me a minute. But when I was in about the 7th grade, so like 60 years ago or more, I had a small transmitter. Maybe I built it with my father. And I had it set up on an old steamer trunk in the basement of my house in Queens, New York. And I installed an antenna from the tree in front of my house to the tree in the back of my house with 2 pulleys so that the antenna would not snap in the wind.
Yep.
And the first time I got on the air, I sent out, the da 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 da, maybe 5 times. And all of a sudden there was a response, which of course I couldn't believe the first time that happened. And the man who was responding was off the coast of Ireland in a ship. I'll never forget the excitement.
Wow. My gosh.
Of that. And there's really, nothing comparable to that feeling of connecting with someone.
That's magical.
In a ship. And by the way, he was equally as excited. He didn't know he was speaking to a puppy, I suppose, until my code speed revealed just how new I was to the hobby. But I just thought I'd lay that in so our colleagues here and friends could hear what a great story, how exciting the hobby is.
Thank you. That's a great story. I love that story. Thank you.
And you're absolutely right. I mean, there's an infinite stream of those. So you had your license when?
1958, perhaps.
And for how long?
When you could still get a novice license?
Yeah. For how long? How long do you have it?
Maybe till 1975.
Okay. And what did you get up to? Were you novice the whole time, or you upgraded?
No, I upgraded to general.
Okay, so you pass your technician, you can get that back.
Well, a couple of years ago I did that, and so my objective here is to kind of rekindle and reawaken some of the technical things necessary to pursue the extra, which would be my next stop.
And what's your call now?
K9JYS, I think it is.
You think?
Well, I haven't used it. I mean, yeah, exactly.
You think? I know what you mean about rekindling it then.
Yeah, exactly.
Well, very cool. And I mean, I could go I've had my I'm 55 and I've had my license coming up on 40 years now.
Wow.
And I could go on and on and on about the stories.
Oh, I bet.
So, well, cool. Thank you for that.
You're welcome.
All right, let's see. Satellite uplink. What's the impact of excessive power going up on the uplink? Block access to other users. You're basically blinding the satellite receiver. Satellites will also send out, kind of like a repeater station, they will send out their own call sign. They send out a beacon, and that beacon contains information about the satellite. That will be simultaneously sent at the same time as what they're hearing and repeating. So if your audio is not particularly louder than the beacon, then that's about the right volume. A LEO satellite is a low Earth orbit satellite. Most satellites that we work with, like the ISS, those are LEO satellites. They cost a lot less money to put up there than geostationary satellites. Again, a beacon contains information about the satellite, health and status of the satellite. It could be the weather, local weather on the satellite. Inside the electronics are 22 degrees Celsius, 42% humidity, and outside it's 200 below zero. It could be just information like that. Who can receive telemetry from a space station? The key here is receive. Anybody can receive anything. What information is provided by satellite tracking programs? This used to be something that was really complicated. It is no longer complicated. I have a satellite tracking program, or just a little app on my phone that allows me to punch in a satellite's name, and it tells me exactly where it's going to be and when. It uses that by looking at the Keplerian elements of the satellite. Johannes Kepler worked on planetary motion, and those values are used to figure out exactly where a satellite is going to be and when. So if you're looking for the International Space Station, you can very easily figure out where the next passes are going to be, how high it's going to be, where to look up in the sky. I can even take my phone, hold it up, and it puts a picture of where the space station is, which allows me to easily point my antenna, and that's actually how I contacted the space station once. Doppler shift. Doppler is the same thing like when a fire truck goes by and goes, the tone changes. That is, we hear that with audio because it's moving at the speed of sound. Those kind of speeds don't have any impact on radio frequency. However, when you get a satellite or the space station traveling across the sky at 17,000 miles an hour, it's actually moving fast enough to stretch light waves, or radio waves in this case, and slightly change the frequency. So you actually have to compensate for that when you're listening for or trying to talk to a satellite going overhead. Spin fading. Satellites typically spin in orbit. The antennas are sometimes obscured by the satellite. That's known as spin fade. All right, how about a 5-minute break, everybody? We're in the home stretch here.
Okay.
Sounds good.
Hey, Scott? Scott, are you there?
I think you walked away to be on break.
Okay, thanks.
Yeah.
Hello, hello.
How's your day been?
Busy.
Didn't do anything? G. Yeah. Or G.
I've got a question for you, Scott.
Uh-huh.
You mentioned I could get my advance.
Yep.
I don't see my certificate that I had, but University of Arkansas has a place you can go and type your ID. Now I don't know where it gets the information from, but it calls out the date that my license expired, my address, etc. Is that good enough?
Possibly. What was your
Hello,
call?
Scott.
Hey, JD. By the way, everybody take a look at JD's shack.
Jeez.
JD has the best shack I've ever seen. It is truly a ham shack.
Let me put a little light on the subject so you can see
Yeah.
what you're talking about.
Okay, so Neil, what was your call sign again? WD6?
Whiskey Delta 6 Golf Kilo X-ray.
I'm looking in the FCC database right now to see if it has anything.
I don't think it does.
How long ago was that, Neil?
It expired in 2004.
It's probably in there.
And what are you testing for today?
The technician.
Just technician?
Yeah.
There is a way we get the proof of the advanced call. What was it? WD4?
No, whiskey.
WV6?
Yeah, right.
Here, I'll bring it up on the
Golf
screen.
Kilo X-ray.
Golf Kilo X-ray.
There it is
Whiskey
on the-
Delta 6.
I put it on the screen.
Yeah, there you go. You got the proof right there. You pass the technician today, and then you come back to the VEC to us and say you held this call in and give us a proof, and we'll validate it. We'll circulate what's called a DocuSign. And once that's all together, we'll just have a 5-minute session and you'll have a general.
Advance?
You won't be able to get your advance back.
You can't? They don't do that?
Well, there's no
you
advance
don't-
anymore. It's extra.
There is no more advanced, and they won't give advanced credit for extra. But you'll get your general back.
Okay, how did you get that on there, Scott?
Just looked in the FCC ULS. Just did a search for it.
Yeah, it's funny. I did that too, but I never found it.
Hey, Scott, do a screen print and drop it in email to him. That way he has it in his email.
Yeah, I'll do that.
Oh, that'd be great. Thank you.
JD, is this adequate for what he needs, or what exactly is the proof that is needed? Because I don't know.
Oh, we got a couple of sources we go look at, and we married it all together.
There you go.
Yeah, send him and me a copy of that.
Okay, I'll do that right now. So, anyway, has anyone figured out who JD is?
He's running for president.
He's not. Well,
Yeah.
that's okay.
Did he write Catcher in the Rye?
I'll tell you by the background, he looks like an amateur operator.
He is. He's actually.
Yeah, I haven't been a ham very long. I started in 1962.
God bless you.
He's our coordinator for the exam today.
Nice.
So, if anybody has any mechanical type of questions, like how this is going to work, if anyone has any questions as to, who gets to go when, and how many people there are going to be, and if you need to go first or you need to go last, and how many people we can examine at one time, he's the guy to ask.
Turn your screen share off.
I have a question about, I can connect my computer to read the test via the Zoom, but where do I connect my phone? Can I also call into the same Zoom location? with the
Exactly.
same
Use
numbers?
same identification that you got, same password on both devices.
Okay, thank you.
And you put your phone to one side or the other of you. When you get in the test room, the lead will say, we need you to move the phone to the right, to the left, turn it sideways, whatever, to get the view they want.
Okay. Thank you.
I have
Sir.
a question if you don't mind.
No, I don't mind. Go ahead.
All right. So if, for say, I live in Maryland, but if I'm testing in Alaska, which is I think where the test location's at, how does?
That's where the VEC is. I'm in Maryland myself.
Oh, okay. Well, perfect. Well, so then how does the call sign work?
You will get a three land call, like what is the current one? KC3QQD, for example.
Okay.
Are you over in Indian Head?
I am in Indian Head, but I'm actually working in the Middle East, so that's where I'm at right now.
Okay, as long as you got a Maryland address.
Yes, I do.
You'll get one Maryland type call sign. It'll have the number 3 in it.
Okay, perfect. Thank you.
So
by the way, I'm in Mechanicsville.
That's not too far from me.
No, hop, skip, and a good throw of a stone.
Is there anyone else who's got any other questions or has not scheduled an exam for today who still wanted to, for instance? Or you are scheduled for an exam and you're just like completely panicked and say, I need another week. This is a good time to say that.
Well, I just received an email saying, wait for the telephone call.
Okay.
That's going to be the next subject.
I will be doing the phones.
There's your phone master right there. And don't call in, don't sign in the Zoom until Scott calls you.
Otherwise, it'll get kind of chaotic. And then people.
Yeah, Scott, this is David Johnson from Iowa. I will not be testing today.
Are you on the list?
Yes.
JD?
David. What's your last name, David?
Johnson. Son of John, not son of John, which would be just wrong in Danish.
Send us a reschedule form, David Johnson.
Yeah, I'm not gonna be testing today either because I'm not ready for it. But this has been a great baseline for me to prepare.
And who are you? Michael
Razzie.
Razzie? Okay, I'll send you a link for what's called a reschedule, and you pick your date and your time.
Okay.
Then you won't have to do all the money thing and
Oh, are you working with Scott, I guess, or?
I will take care of the rescheduling for you, no problem.
Okay.
Quick question. If
Yes, ma'am.
If we want to just go for it and we don't pass, can we just sign up again tomorrow or the next day?
Sure, you can sign up in 10 minutes if you want.
Okay. Thank you.
You betcha.
You're going to do it, right, Sue?
Oh, I'm going to do it. I'm not ready, but I'm just going to go for it anyway.
Okay.
And
You're
if
going to surprise yourself.
Well, if I can always take it again.
You betcha. You don't make it today, you can come back tomorrow.
I once got a jump hug in an in-person session.
What is that?
Somebody passed who really didn't expect to, and she said, "Oh my God!" and she jumped up and hugged everybody. So,
well,
yeah.
Why not?
Why not?
I've been in this testing business a long time, and I've seen people who come in and say, I'm scared, I can't do it, I'm not going to make the minimum, and they ace it.
I don't think I'm that. I don't think I'm that.
Don't be afraid of it. It's nothing to it.
And it's not like you haven't seen it because you've been taking practice tests. So, and there's nothing that can be on the exam that hasn't been on a practice test.
I think I'm getting to the point I want to get past the threshold of memorization and try to understand it better than just memorizing.
Oh, we've had an excellent teacher. Thank you, Scott.
Absolutely.
JD, did you see the note from Donaldson? Or was that just for me?
Donaldson.
There's.
Yeah, we're not to everyone.
No, I haven't got a note from him.
Okay. Oh, it's in the chat. Okay.
Scott,
Oh.
Craig?
Do you know a guy named Roland Anderson, I think? It's
Raul
Yeah,
Anderson, yep.
Raul. Yeah, our K3R.
Yeah, he taught this kind of like something like this 2 years ago, but I couldn't. I got pulled away and I couldn't get back into it. So it just, I said, I'm doing this today. So but it was like over like 4 hours for 3 weeks or something like that, or a couple hours a week.
And he's got one going right now. As a matter of fact, I think it's, yeah, like you say, 4 hours, about 6 weeks.
Something like that, yeah.
Yep.
But
Okay, so Craig, what's your wife's name? I don't have the list in front of me. So Craig Donaldson and Terry Donaldson. So JD, our exam session is shrinking. Get out of there faster.
It's been doing that all day, Scott. It's been going up and down. We're up as much as 26 and we're down to 21.
Okay.
Question about that link for the exam. I got called into work, so I'm actually going to have to finish this class while driving to work. Can I use that link to schedule it for sometime next week, or is it going to be expired by then?
No, I will send you a reschedule link. You pick what you want, and we'll put you right back on the roster. And you people are going to get this link. You fill it out, read the questions. It'll tell you exactly what to do. And you submit it after you picked your date. And that's the end of what you have to do. You don't have to pay again, and you don't have to do the exam agreement again. We just carry that forward for you.
And that was Matthew?
Yes. No, I didn't sign up for it because I was waiting on a phone call this evening.
Okay. All right.
So that was my question.
Yeah, then you would just sign up for another open session.
But the link that you sent in that email, I can use that link, or is there another place I need to go?
I'll send you a new one.
All right.
A reschedule is what
Well,
it's
he
a
hasn't
reschedule
scheduled
form
at all
we
yet.
call you.
He hasn't scheduled at all yet.
Right.
Yeah.
So
I never find out when I'm going to get hit for overtime until either midnight or the day before or lunch the day of. So I kind of
Little.
have to.
Yeah. Mike Little, you're not on the roster anyways. Go ahead and submit whatever day you want. Do both questions. There are 3 steps, and you got it made.
And in order to find a list of sessions,
you go to hamstudy.org, HAMSTUDY Oscar Romeo Golf, hamstudy.org. We test every day of the week, twice a day, 3 people per session. Got plenty in there. We got the calendar out to, I think it's out to the end of October, so you got plenty to pick from.
is it the $15 per testing or something like that? I see the prices
10.
there.
10.
Oh, 10.
You can charge up to 15. Anchorage charges 10.
Okay.
Hey, JD, are you part of the CCARC?
Yes.
Yeah, I thought you looked familiar because I was back home in January and I joined, me and my son.
Oh, okay. They didn't meet over at the Library Church.
Yeah, exactly. We came out and did the off-grid power bricks supply build.
Very good. Okay. Anybody else?
Yeah, I'm sorry, I didn't get your name, and I was not here when you came on, so I wasn't sure what the affiliation was with everything. So.
I'm JD. I'm W1JD, and I'm with the Anchorage VEC. I'm the session manager today to get you people tested.
Oh, I see. Okay. All right. Nice to meet you, by the way.
Thank you.
So, is there anybody who needs to go early or needs to go late?
I'd like to go early if it's possible.
Okay.
Same for me if possible.
Okay, so name? What?
Irene Park.
Park. Okay, and you're on the list. Okay, so that's an early. Okay, who else was early?
Jake.
Last
or
name?
Jacob. Jung, Junge.
Junge.
Yes.
Junge.
Okay.
Correct.
Okay.
I'm on the list, but it don't matter really what time that I go today.
Okay. Is there anyone who specifically wants to go early or late?
I would just soon go early. It's a deal.
Okay.
Scott, I'd also like to go early if possible. It's Aaron
Last name
Smith.
Okay.
Got me to Vladimir Hydrovo.
Okay. And that's pretty much, then we're going to be rolling into just like the bulk. So,
Scott, what's the window? It's
usually,
I'm on West Coast. I'm on
it'll
Pacific
be about 2
time.
hours. It'll probably be 2.5 hours.
Well, JD, you can put me wherever you want me to be.
We'll let Scott be the
That's me.
gatekeeper.
Yeah, I'm the phone.
All right.
And everybody, make sure that if you see a number come up that you don't recognize, please answer it. Because it's probably me. And I'll be saying, it's time for you to sign it. It's time for you to take your test.
Yep, it's the time.
I'm still waiting on the call then.
I know. No, we're not doing it yet. And this is at 2 p.m. Pacific, 5 p.m. Eastern, right?
Right.
Okay. Cool.
And
JD, thank you.
Just remember, it's a 35-question test. We're not in a hurry here. You don't have to rush through it. Take your time. Make sure you got it the way you want it. Usually your first impressions are the correct one. If you got an answer that may be really driving you nuts, why did I pick that? Go ahead and change it. But first impressions are usually right. You take all the time you want. Just remember I turned into a pumpkin at 11 o'clock at night. And somebody will have to bring you a pizza. But other than that, don't worry about it. Don't get flustered.
Hey, JD.
It's going to be fine.
What,
Yes,
JD,
sir.
what does your shirt say? It's a radio shirt, right? Oh.
Well, of course. What are we doing
I
here?
can't. Yeah. See, and did you see what mine says?
So many QSOs, so little time.
So many QSOs,
Yep.
so little time.
And the other thing I was going to tell you is you guys were talking about a rabbit a while ago. When I lived in Anchorage, a woman down the street had one about 4 doors down from us. And she had a teenage daughter. I forget her age. She was talking to her boyfriend one night, and they were getting really.
Okay,
my daughter says, "Oh, that's," I'll pick a name, Sherry, and she goes, "Run out the door, slam." I heard that. She's running down the street, 4 doors. Heard the door slam on that one. They're hearing you up the street. They're hearing you up the street. And all of a sudden, it went off the air.
Oh God! Oh jeez.
It sounds like only radios.
It was funny.
Nobody can keep a secret.
There you go.
Yeah, there was nothing. There was nothing racy.
Alexa does that too. That happened on Alexa's too.
And Alexa.
In series, they had that problem too, where someone was having sex on somewhere else, and no one pushed a button.
I swear Alexis listens anyways.
The lady I work with, she had one of those Alexa when they first came out, and she had her brothers and family came over, and they start raising a lot of Cain. They were joking around, and then one lady goes, "I'm going to call the damn police on you people," and joking around. Next thing you know, it was literally. She said, "Honestly, God, when the police walked in, they knocked at the door." She goes, and they're all shocked, like, "What are you guys doing here?" Well, you called the police. So, I didn't know. She said it happened at work, so I was like, "Oh my gosh!" So, oh wow.
I had a test related question.
Yes.
After having taken this, I live within about
Can't hear you very well.
maybe a mile and a half of my local. Can you hear me? Is that any better?
Yeah.
I'm sorry. Did that help?
Yeah, go ahead and try again.
Okay. Anyway, I live about a mile and a half from my county's ham club, amateur radio club. I was wondering, after having taken this, is it my understanding I just contact them and say, "Hey, I'd like to take the test," and they put me on a list, and then the next time they throw it.
You totally dropped out again. Try turning off your video.
Yeah, let him kill his video.
I think he was just asking if he should contact his local club to take the test.
It sounded that way. Yeah, I mean, it depends what they operate like. I mean, I don't know how often they give them or.
That's the way it works, or how does that work?
Okay, that connection is not working.
Damn.
Okay, wait, try now. I heard damn.
Does
Try
that
again.
help?
Yeah, that helps. Yeah, go
Yeah,
ahead.
whatever you did.
No. Can you hear me now?
Yes.
Yeah, just make it fast.
You hear me now?
Yes, go for it.
Verizon guy.
Nothing.
Friends don't let friends use dial-up.
Yeah.
Okay.
All right.
Digital
Well,
mode.
all right, we're gonna go finish this. We're gonna go finish this class.
Yep, y'all. I'll see you here in about an hour and a half.
Yep.
And good
All
luck
right.
to every one of you.
Thanks, JD.
Thanks, JD.
Thanks, JD. It was nice,
Sure.
nice talking to you.
All right, here we go. Operating activities. Okay, one of my favorite things to do on the air, because I'm a competitive person, is contesting. You basically will, it's an organized event where people will get on the air and make as many contacts as they can, given a certain set of rules during a certain set of time, during this period of time. Good procedure when contacting another station in a contest. You have to know what the rules of the contest are. It might be just your name and your state. That's all you say. Name and state. You give them your name and state. Grid locator. This is one of the things that I sent out as part of the information packet. One of the things I sent out as part of the information packet. There's a grid square map, and it, if I find it, it looks like this. So the entire globe is broken up into 324 big grids, which are 20 degrees in latitude, or sorry, 20 degrees in longitude by 10 degrees in latitude. Each of those is broken up into 100 smaller grids. So there are 32,400 grids on the globe. And the purpose of this is that it helps to more closely identify where somebody is and where to point your antennas. Radio direction finding is a good way to find interference or jamming. Again, the story of the radio direction finding that we did, we sometimes go out and do it on purpose. We take a little transmitter and we stick it somewhere in a park and don't tell anyone where it is and say, okay, go find it. So you use a directional antenna and use typically a handheld radio, and you walk around and look for it and try to find it.
Is that commonly called fox hunting?
Fox hunting. Okay. We also call it bunny hunting, DFing, direction finding. IRLP, Internet Radio Linking Protocol, is a technique for using VoIP, which is VoIP, Voice over Internet, for connecting radio systems, repeaters, and such over the Internet. So VoIP or VoIP is a way of delivering voice communications over the Internet using digital techniques. Once it's digital, it becomes more immune to noise. Of course, then if something goes wrong and, like we just heard somebody trying to talk, and that's what happens if you have packet loss. Echolink. Echolink is another system on the that's computer-based and also phone-based, tablet-based. Once you have a license, you can apply for an Echolink account, and they give you your account, and then you can connect to any of thousands and thousands of repeaters around the world that are connected over Echolink from your phone anywhere in the world that you have an internet connection. I've actually used this many times when traveling to connect to my local repeater back here in Oregon to participate in nets and other activities. What can you use to transmit through a repeater without using a radio? You use Echolink. You actually use your phone. Yep.
Is that for any license?
Is
that for any license?
Well, what do you mean any license?
For technicians or?
Oh yeah. Yeah, any amateur license. How do you connect to an IRLP node, Internet Radio Linking Protocol? almost every handheld has these buttons. These buttons, in addition to being able to program things and punch in numbers, are also used when you're holding the push-to-talk button, which is on the side, for sending touch tones. Touch tones are used to open up Internet Radio Linking Protocol. That's known as DTMF. Nodes are also gateways. A gateway is a station that connects other stations to the Internet. Okay, now we're into rules and regs. The FCC regulates amateur radio in the United States. The FCC has Part 97, which is all of the rules and regulations of the amateur service. Notice these right here. Basis and purpose. This is one of those 5 rules of what makes the amateur service exist and why it exists. The justifications. A beacon is an amateur station transmitting communications for the purpose of observing propagation. So I could put up a beacon and it says, for instance, N7JI CN84. That's it. It says, this is who I am, this is where I am. Somebody hears it, they say, oh, okay. Well, if I heard them on the 70 centimeter band and I was pointing the antenna in a particular direction, I know that there's a propagation opening between here and there. That's a beacon. A space station is any amateur station more than 50 kilometers above the Earth's surface. When are you allowed to interfere with somebody else on purpose? Never. Even if they make you mad. Never. Which of the following entities recommends transmit and receive channels and other parameters for auxiliary and repeater stations? In Oregon, we have the ORRC, or Oregon Region Relay Council. That is a volunteer frequency coordinator. Every state, every section has one. Who selects the frequency coordinator? That would be amateur operators in an area whose stations are eligible to be repeater or auxiliary stations. Frequency allocations and power limits. Okay, this is just memorization. What are the limits on the 6 meter band? 50 to 54.
54 megahertz.
50 to 54. Okay, so the only one that is in there is 52.525. It turns out that's actually the 6 meter FM calling frequency as well. What amateur band includes 146.52 megahertz? Well, 144 to 146, 148. There you go. That would be the 2 meter band.
2 meter band.
And this is just memorization. On which HF band does a technician class operator have phone privileges? Phone comes from the word telephony, which means voice. So if you take a look at this, you will see novice and technician voice is this blue hatched area. So a technician operator can operate on the 10 meter band, or at least part of it. And in fact, there's your little sub band, 28.3 to 28.5. Where can single sideband phone be used in amateur bands above 50 megahertz? Well, single sideband is the light green. There's a spot, 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 there's a spot. So, all of them. There's at least some segment of all amateur bands in the VHF range, UHF and above, that's usable for single sideband. Band segments that are limited to CW only. Take a look at the map. CW, we're looking for the red areas. Well, there's one. There's another one. This one we don't really talk about too much. So it's this one and this one. And the answer is that one and that one. So, okay, this is a really kind of a weird one. Notice that this mentions the fact that how can amateurs use the 219 to 220 segment of the 1.25 meter band? What do you notice about that? What are the limits on this band?
225 megahertz.
222 to 225. Where's 219 to 210?
It's not
219 to 220.
It's before.
Yeah, it's not even
Not
on
even on
this
the map.
map. So the reason that it's not even on this map is that it's like, in addition to almost being never used, the reason that we used to have 220 to 225. And a long time ago, there was a proposal to use and repurpose. So you remember when I said that it's really important to participate and be a stakeholder in making sure that we have representation on Capitol Hill. A company said a national package delivery company said we want to repurpose 220 to 222, which isn't heavily used, for our tablets, for our package tracking. And they said, in exchange for 220 to 222, we will give the hams 219 to 220. So we gave up 2 megahertz and we got 1 megahertz. And we used to be able to use it for whatever we wanted. The new one we can only use for fixed digital message forwarding systems only, which means basically very few people use it for anything. So we lost 2 megahertz of something that was very useful and gained 1 megahertz of something that almost nobody uses.
What was the advantage of that?
For
Would
us,
this be
nothing.
UPS?
To the company?
Yeah, for
UPS
the company.
and FedEx?
Yeah, I think it was UPS, but I'm not 100% sure.
Yeah.
I think it was UPS.
Interesting.
So, how do we protect our frequencies? We use them. The other one is we join ARRL, and the ARRL is kind of our watchdog.
Lobby.
Yep, the lobby on Capitol Hill and lobby in front of FCC on our behalf. And they represent, it should be more, but it's 160,000 people. It's in particular, it's a lot of really active amateurs. I wish it were more. It should be more. I will always push it to be more. Why should you not set your transmit frequency to be on the very edge of an amateur band or subband? Well, your radio could drift. Your radio might not be calibrated that well, or your sidebands do not extend beyond the band edge. So we're going to take a look at this band here. Let's take a look at 15 meters. Notice that we go from 2100 to 21450, right? Okay. What frequencies within that band are we allowed to use? Come on, somebody tell me.
21.025 to 21.2.
No, as hams, what frequencies between 21.0 and 21.45 are we allowed to use?
No.
They're open.
Anything. We can tune anywhere in there. There's only one requirement. What's the requirement?
Shit.
What's the requirement?
Yeah, but for class for all of that stuff.
You make sure nobody else is using it.
Right, but what else? All
Did
of
you
our
stay
signal,
within the lines?
Right, our signal has to stay completely inside the lines. That's the only requirement. So, notice it says modulation sidebands. We're going to draw a picture. Oh, that's ugly. We're going to draw a picture of upper sideband. Upper sideband looks like this. How wide is a single sideband signal in kilohertz? Does anybody remember that?
3?
3.
Yep, 3 kilohertz. So, what if you, on the 15-meter band, you tune your frequency to 21.449? Well, that's still below 21.450, right?
Yep.
Okay, what's the problem?
You got to go past it because your
channel
bandwidth
width is too big.
Yep, your sideband is going to extend and you're going to spill over the edge of the band. So, that's another reason why we're taking a class. You have to be able to understand modulation and what your signal looks like to make sure that it stays entirely in the band. You don't want your sideband to go outside of the lines. That will get you a note. Typically not a fine, at least not if it's an accident, but it'll get you a little note. Okay, how are U.S. amateurs restricted in segments of bands where the amateur service is secondary? The concept of primary and secondary, we are often secondary users of a frequency band. For instance, on the 70 centimeter band, we are secondary on the entire band. We are a secondary allocation, which means that the military actually is number one, which means that if the military decides to use it and they show up and we know it's a military station, we actually have to let them alone. We have to not interfere with them because we're not primary, we're secondary. Except for some specific restrictions, the maximum peak envelope power for technician class operators above 30 megahertz is 1,500 watts. Another very good reason why you guys are in a class. 1,500 watts is a lot of power, especially at certain frequencies. It can cause some significant bodily damage.
It's got a question. Is this like no matter what country you go to, are this all applies to every country?
No, the rules are different everywhere you go.
Interesting.
Yep. When I went to Canada and took my Canadian license exams, I had to learn all the Canadian rules.
Wow.
Yep. What is the maximum? I mean, RF is RF, electronics is electronics, but the rules are all different.
Okay, I was just
there's a lot of overlap, but there's a lot of not overlap too.
Interesting.
What is the maximum peak envelope power for technician class operators in the HF band segments? HF is what frequency range is HF? Everybody?
Kilowatts.
Yeah, what's the frequency range for HF, high frequency? How many megahertz?
30 to 300. 30 to
HF?
300.
No, for HF?
3 to 30.
3 to 30.
Oh, you're right. 3 to 30. Yeah.
Right. So you look at the HF band segments. You have this little green hatch, this green hatch, this green hatch, this blue hatch. The band limit for HF is 200 watts, which is still a lot of power. Okay, for novice and advanced classes. Well, we actually had the discussion of advanced today. So apparently you can't get your advanced class license back, but you can get your general class license because the FCC does not assign advanced class licenses now. So we only have technician, general, and amateur extra. That's the answer for that one. The normal term for an amateur license is 10 years. They don't even send you a piece of paper anymore. You just appear in the database. If your license is listed as active in the database, you have a ham license. You can go and print out a copy. You can download a reference copy or an official copy if you like. I have one on my wall. I have one in my wallet just because. But really, that doesn't mean anything. The only thing that's important is that it shows up in the database. You can hold one license. That's it. You can hold exactly one license. What proves that the FCC has issued a license grant? The license appears in the database.
Database, yeah.
All right. Who can request a vanity call sign? That would be any licensed amateur. A vanity call sign, if you want your initials and it's not taken by somebody and it follows the call sign procedures. The United States is assigned WNK and AA through AL. If it matches your license class and it is a valid U.S. call sign that you're able to get, because let's say you live in Three-Land, which is the Mid-Atlantic, Delaware, Pennsylvania, D.C., and Maryland. You want, for instance, N7JI. You have a technician class license. The N3 is a 1x3 call, N3ABC. You have a technician class license. Technician class licenses can hold 1x3 calls. If it's available, you can request it. It doesn't even have to be a match to the number. My wife actually has a 3 call. She lives in Oregon. That would normally be a 7, but she liked the 3. So she went for a 3 call. She has a technician. She got K3LUX. I know, for instance, if she were to go for W3AA, that would not be valid because that's an extra class call sign only. That's known as a 1x2. It's the number. It's the number of letters before and after the number. So that's a 1x2.
Oh.
Okay. Here we go. KF1XXX is a valid technician class call sign because it's 2 letters before the number and 3 letters after. That would be a 2x3. 2x3s are valid for technicians. The one after it, KA1X, that would be a 2x1. That's extra class only. W1XX, that's a 1x2. That's also extra class. Grace period, it's good for 2 years after your license expires. Don't let it expire. Because even though it's still in the database, you can't use it during that time. You can renew it, you can get it back. Once it's in the database, you can use it again, if it's listed as active. Okay, a club, the concept of a club. A club is listed as by the FCC saying it has to have at least 4 members. The assumption is that I would assume that they're officers, president, vice president, secretary, treasurer. So 4 people makes a club. If the FCC is unable to reach you by email, it used to be by snail mail only that they would they would have a problem. If your email address bounces and they are trying to get a hold of you, they can actually pull your station license. If the FCC...
So I have a question.
Yeah.
So the original FCC database I created, my FRN with the GMRS, is it okay if I just update to?
Is it your personal one?
It's one that I had before, and I've created a new Gmail account so that I can have all my radio material go to that one. Do I just go to update it there?
Okay, so do you have a second FRN now?
No, I have still just one FRN.
Okay.
And
that's what I'm saying. Is it your personal FRN or is it for like a company name?
Oh, no. It's my personal. I'm sorry.
Then you would just use that FRN for your ham license too.
He just wants to update his email address, I think.
Yeah, that I want to make sure that it's got the current email address, especially, to make sure I meet all the requirements. So I should be able to. I should be able to just go there.
You should be able to change it. Yeah.
Okay.
You just basically sign in and manage your account, and I think it should work. And the other thing is that the FCC, the licensing bureau, is actually really good about answering the phone. It's one of those rare agencies that they actually seem genuinely happy to help you when you call them, and they actually seem to care about answering the phones and making things work for you. I've had that I've actually had that experience personally. So, and so have other people. They're very good at what they do.
Good experience. It's good.
Okay, again, what can result in revocation of the station license or suspension of an operator license? That would be failure to provide and maintain a correct email address.
Wow.
FCC can transmit from any vessel or craft in international waters and documented and registered in the United States, at least legally. It doesn't mean that the captain is okay with you doing it. You need to ask. But if it's an American flag ship and you're not the captain, you are the captain, you're able to use your call sign. You would typically say your call sign /MM for maritime mobile. Authorized and prohibited transmissions. Restrictions concerning transmission of language that is considered indecent or obscene. We are not allowed to do that. Essentially, the good rule of thumb is imagine that you're talking to somebody and there is an 8-year-old listening to what you're saying. Because there very well could be. If it's nothing that you'd want an 8-year-old to hear, don't say it on the air. We also try to avoid religion and politics, just because there's a lot of room for friction. There's a lot of other ways to talk about that stuff, so we just try to avoid it. Under what condition is an amateur station authorized to transmit music using a phone emission? Typically, we are never allowed to transmit music. However, we are occasionally allowed to transmit music if it's incidental, like if you happen to be at like a street fair or something and there's music in the background, I wouldn't worry about it. However, the time that we are actually intentionally allowed to intentionally transmit music is when we're waking up astronauts on the ISS. It used to be that NASA Goddard Space Flight Center and Johnson Space Flight Center and I think out at JPL, their ham clubs would retransmit all the space shuttle stuff. Their repeaters
cool.
would retransmit all the space shuttle stuff. And if you remember if you remember the space shuttle, they would wake people up by playing music. So that was part of what they sent up there. And like, well, how are we going to bypass that? So they got a special rule as part of the FCC rules that permits them to wake up astronauts and retransmit it over the air. When is it permissible to transmit messages encoded to obscure their meaning? All right, so it could be said that we are never allowed to obscure the meaning of a message. That could be talking in code. That could be sending a code that nobody else knows. You're allowed. Then you would say, well, you know what? If we're listening to a digital mode, how does anyone get away with that? Well, basically, if the key is well known and published, then it's okay to use. You're not allowed to use something that's proprietary or secret. Now, the one time that this doesn't hold true is if, let's say, you're running a satellite or you have an RC plane or something, and you're trying to keep it from being taken over and crashing. We're allowed actually to encrypt our signals to make sure that doesn't happen. We can only communicate with amateur stations in countries where their local licensing agency is okay with it. The International Telecommunications Union, or ITU, is kind of like it's the UN consortium on communications. If a country that licenses their hams doesn't want licensed hams in their country to be allowed to talk to another country, they will actually file something with the ITU.
Oh, really?
Yep. For instance, there was a group of hams who went to Socotra Island in Yemen. I think the call sign was 706T a few years ago. And they were Italian, and they were told by the Yemeni government that we will license you, but you have to sign this that says, obviously, you're going to follow our rules of licensing. And one of the rules says you can't talk to Israel. It was only a few hundred miles, but they weren't allowed to talk to them.
Oh, wow.
Because they were technically, I guess, still at war with them. And so they said that they have a standing order with the ITU that said they weren't allowed to talk to Israelis. So they never could make contact with them. If they did, they would get their license pulled, possibly thrown out of the country. So, in which of the following circumstances can the control operator of an amateur station receive compensation? Now, remember we said we are a non-commercial service. Non-commercial means we don't make any money. However, if you are a physics teacher or something and you are using ham radio as part of a class demonstration of waves, for instance, or communications technology, let's say you're teaching an aircraft, a class on aircraft communications, you can use ham radio as a demonstration and still make your salary. So you don't have to give up your salary just because you're using ham radio for classroom instruction. When can you use your station to notify other hams of the availability of equipment for sale or trade? It has to be somewhat related to amateur radio, and you can't run a business doing it. So, if you do it a couple times a week, that's probably okay. If you have a truckload of gear that you're trying to sell, and when you sell something, you get new gear, probably not okay. You should probably have a storefront. If you're selling a computer for a ham station, that's probably okay. If you're selling a couch that could be used for a ham station, that's a little more questionable. Okay, how do we define broadcasting for the amateur service? A broadcast is intended for the general public. Hams do not typically broadcast. We transmit. We can do one-way transmissions. One-way transmissions are intended for the entire amateur population. Broadcasting is by definition intended for the general public. When are we allowed to assist in broadcasting or program production? Here's that rule again. When it's related to immediate safety of human life or protection of property. If there are no other means, We are allowed to do whatever is necessary for for safety of human life or protection of property. Okay, so what are we allowed to do? Communications incidental to the purposes of the amateur service and remarks of a personal character. I used to laugh at this because when you are at a certain age, what is really important to you? Come on, everybody. There's some people here of a certain age. What's really important to you?
Sleeping through the night.
Sleeping through the night. Or, oh, I got a doctor's appointment. My sciatic is out. Okay, when I was 15, I used to laugh at this, right? I had my license. I'm on the air. I'm laughing because you get the people who are complaining about how bad their hip hurts. And, oh, I got to go to the doctor's appointment tomorrow. And, my kids don't want to come see me. And I used to think it was funny. And now I don't think it's so funny, right? Because I really do have a doctor's appointment. And my sciatica really is acting up. But those are comments of a personal nature and remarks of a personal character. Essentially, you're talking about your life. You're talking about somebody else's life. We talk about a lot of other stuff too. But that was always one of my favorites. All right, control operator and control types. When are you allowed to operate without a control operator? A control operator is the person who is responsible for what is being transmitted, and the answer is never. Now, a control operator can be in control of a system that is operating automatically. Technically, you're still the control operator because your name is associated with it. We have a repeater that's up on a mountaintop. I am not physically there at the repeater site. It is an automatic system. Whatever comes in, if it's got the right criteria, if it meets the right criteria, will be sent back out, whether I'm there or not, whether I'm listening or not. But technically, I'm still the control operator. If something goes wrong and I happen to be listening, I can shut it down from here remotely. If something goes wrong and I'm not listening, somebody will typically call me. Who does the FCC presume to be the control operator unless documentation is in the station records? So notice we have a couple of different things here. We have a control operator, and then we have a station, and we also have a licensee. These are actually kind of different things, aren't they? So there are two parts to an amateur license. There's an operator license and there's a station license. The operator license gives you the ability to operate a station. The station gives the call sign of that particular station and says this is an amateur station. The station licensee is assumed to be the control operator who is in control of the station, unless there's something in the records. So now here's another question. Let's say you have a club station. We have a club station. It's W0AXE at South Eugene High School. The mascot, the school mascot is the AXE, AXE. The call sign is W0AXE. Somebody named Sue, who very well will be on our in our exam session today, is the trustee of that station. What operating privileges does that station have? What do you think? It's just a station.
It would be under the technician's license.
It has none. It has no privileges.
Wait, all right, say that again one more time.
It's a station license with somebody's name saying they're responsible for it, but it's only a station license because it's a club station. What privileges are associated with that station? In other words, if somebody walks in off the street who's not a ham, can they use that station?
No.
No. The privileges convey with the person using it. The station itself has no privileges.
Okay, so you said Sue, who is taking the test today.
A different
Oh,
Sue.
not taking the test. I'm sorry.
A different Sue.
Gotcha.
Oh, okay.
No, a different Sue. She's actually W7QF. She's awesome. Okay. Who must designate a station control operator? That would be the station licensee. When the control operator is not the station licensee who's responsible for proper operation, that would be both of them. Who's accountable if a repeater inadvertently retransmits communications that violates the rules? A repeater is automatic. I cannot be responsible for all the bad stuff that everybody does, even if it uses my repeater to do it. So it's the originating station, which means somebody who sent out offending, curse word laden phrases or something like that. That's not my fault. Again, I might do something about it, but it's not my fault. What determines the transmitting frequency privileges of an amateur station? The class of operator license held by the control operator. Again, if it's a club station, there is no control operator listed. Therefore, whoever walks in, their privileges conveyed to the station.
I see.
When can a technician class licensee be the control operator in an extra class band segment?
No.
And the answer is never. Doesn't matter, even if the club station has a trustee that's an extra class operator, they can't do it. When can you transmit through a satellite? That is, if you're allowed to transmit on the uplink frequency. Even if it retransmits it somewhere else that you're not supposed to be, you didn't put it there. An amateur station's control point is the point at which the station is operated. This handheld radio is an amateur station. This is the control point, the push-to-talk button. That is my operating position. Remote control is operating a station over the internet. In remote control is very popular now because you can be on vacation, you can be at your summer home, your station is way, way, way over there, 1,000 miles away where it's really cold and you're in the sunshine. You can still operate your equipment over the internet. So the control operator has to be present. The control operator must be at the control point. The control operator must always be there and must indirectly manipulate the controls. And if something goes wrong, they should really be able to shut it off. Automatic control, again, a repeater. And I believe this is the last section. Yeah, it is. You have to transmit your call sign at least every 10 minutes during and at the end of a communication. You do not have to give it first at the beginning, believe it or not. It just has to be every 10 minutes and at the end. We're allowed to send a signal without identifying with a call sign when using a model craft, like an RC boat. In the United States, you have to identify if you're using phone. You have to identify using English. Phone, again, is telephony. You have to identify in English in the United States. Another way for identifying yourself, look at that. You can use Morse code, CW. You can always use Morse code. Most repeaters actually use Morse code because it's in the background behind somebody talking. Regarding the phonetic alphabet is strongly encouraged to be used. Then there's a concept of tactical call signs. Race headquarters, aid station 1, aid station 2. They are operated by hams. A tactical call sign is not a substitute for your actual call sign. You have to give it at the end of communication and every 10 minutes. So the rules don't change. You can call yourself aid station 1, but you still have to follow the rules, which is that aid station 1 is not an FCC call sign. Regarding calling yourself something else if you are in a different place, so let's say KL7CC travels to Philadelphia, which is in W3. These are self-assigned indicators that are not necessary to be added, but if they are doing it, you can say stroke, slash, or slant. All of those are valid, so all the answers are correct. Third-party communications. A third party is somebody who is not licensed. And depending on, in the United States and Canada, for instance, we can talk to third-party people so long as there's a licensed control operator sitting next to them. So it's a message from a control operator to another station on behalf of a third person. That's the third party. We do this with kids all the time at our local museum. Which of the following restrictions apply when a non-licensed person is allowed to speak to a foreign station? The foreign station must be in a country with which the U.S. has a third-party agreement. Believe it or not, even though you can pick up a cell phone and call virtually any country in the world, we are not necessarily allowed to do this on the air. The reason being that when a lot of these rules were made regarding third-party operation, the government of said country, say Germany or England, actually ran the telecom bureau, ran the phone company. So why would they allow their people to basically sidestep long-distance charges, which were going to go to the government, when they ran that company, essentially taking money out of their own pockets? So that's how that came to be, that certain countries still don't allow third-party communications. And finally, if the FCC knocks on the door, you have to answer the doorbell. You have to answer and let them in and explain to them that they want to see your equipment. You got to show them your equipment.
Wow.
And that's the whole thing. Wow. You've now heard everything there is to know until you get to the general class license.
All right, let's start the general. Ready, go.
Oh, yeah.
All right, quick question about the when you identify yourself. Does communication mean at the end of my statement, or when I'm done talking to you?
That is that is open to interpretation. If you know that there's a chance that you're not going to be talking again, you give your call sign. If you're in a conversation with somebody and it's kind of like a going back and forth and back and forth and back and forth, and you're going to have another chance to talk again, and you don't think that that's the end, then you might not give your call sign. You know, one of the things that happens is that you're in the middle of a very interesting conversation, and you sort of lose track of time, you know? So, and if you lose track of time, you have to remember there has to be a little bell that goes off in your head that says, oh, it's been 10 minutes, I better identify.
Oh, wow. Okay.
Question about the 10 meter and the telephony.
Uh-huh.
Can you clarify that for me as regards to the use of telephony as a technician? Like, is that just regular communication over a microphone, or is it?
It's voice. Right here. Novice and technician voice. Notice the blue hatched area down there?
Uh-huh.
And you go up to the 10 meter band, and you see you have the blue hatch between 28.3 and 28.5.
Okay.
So you have phone privileges on that portion of the 10 meter band.
But, so, and that's my question. Phone privilege. What do you mean by phone privilege?
It means you can talk.
That's all that means?
Yeah.
Oh, okay. I'm thinking pick up a I'm sorry.
You mean a telephone means?
I'm thinking, hooking up some kind of like a digital device, making phone calls over to.
Telephony is just voice.
Okay.
Voice.
Thank you for clarifying.
Fancy name.
I did the same thing. I did the same thing when I was taking the test the first couple of times. I kept confusing the phone with talk, so I completely get that.
And so if you start looking also at different modes that are sent, for instance, there is this. Notice these emission modes: A, F, G, J, P, W, etc. So these emission designators. These are all designations of what a modulated signal is, how a modulated signal is called out. So, like for instance, J3E is actually single sideband. So they all have, technical descriptions as well. So, depending on what you're using, certain modes of operation are permitted. Certain modulation techniques. Certain modulation techniques may not be. So.
Question.
Yeah.
How do you do your call sign letters?
In what way?
Well, I mean, like you said, like
Phonetics?
yours is like you said, J.
I mean, like
You said your like your
like November 7 Juliet, India.
yeah.
That's
But
it.
I mean, yeah. But I mean, do you pick it or does FCC have to pick it for you?
Oh, your first license will have a sequentially assigned call sign. Depending on where you live, that'll determine which series it's from. So where do you live?
I'm in Oregon right now.
Okay, so if you have an Oregon
In
address,
Eugene.
if you
Yeah.
get an Oregon, if you have an Oregon address, you'll get a 7 call. And they're
Okay.
still assigning like KK7U or V in that series. Beyond that, you can apply for vanity call, and you can pick any vanity call that is a United States valid call sign and appropriate for your license class. So occasionally we'll see, like, I don't know, this is true. We'll see this on Facebook or something where somebody applied for the call sign, for instance. Hold on a second. Someone applies for like this call sign. Come on, now my whiteboard is going to work. Is that the way you're going to be? There we go. So somebody will apply for like B1LLY. And like, oh, well, it's not allocated. It's like, yeah, there's a reason why it's not allocated. What's the reason it's not allocated?
Somebody's name.
It spells out Billy.
Format allowed.
Well, that'd be fine. I mean, you could do W1LLY.
Yeah, but it spells out Billy.
So, why isn't it allocated?
B is not a valid.
It's not a U.S. call sign. This is China.
Yeah.
So somebody didn't know the rules, and they applied for a call sign that the FCC couldn't possibly give out because the United States only has WNK and AA through AL.
Well, they didn't do their homework.
Yeah, exactly. Like you really went to all the effort of applying for that when in fact you couldn't possibly have been given it anyway. And so I know that somebody at the FCC got a good chuckle out of that.
Yeah.
So when you get licensed, they give you a sign, and then afterwards you can apply to get it changed. Is that how it works, or do you apply?
KK7 VAC, and you could even do it the day that it gets assigned. You could apply for a vanity call. You pay your extra $35, and
so then do you have 2 call signs, or do they replace one with the other?
It replaces it. You only get 1 call.
What's the numerical designation for the state of New Jersey?
2.
2.
Yep.
Okay.
So if you look at the U.S. call sign map, there we go. New York, New Jersey is 2. Northeast is 1. Pennsylvania, Maryland, Delaware, and DC is 3. And notice 7 is huge. It was kind of like a catch-all. Everything else except for California. And the other thing is you cannot apply for a call sign that's affiliated with Alaska or Hawaii or Puerto Rico or the Virgin Islands, for instance, or Guam if you don't live there.
Just gotta have a question.
Mm-hmm.
So if you get your license, like for example, Texas is a 5, right? And I'm in Texas, and then I move later on to, let's say, New Jersey, and then does my call sign changes the number to be in New Jersey?
It doesn't unless you want to apply for a change.
Oh, okay.
It used to change. Actually, there was a requirement back in the 1950s, 1960s. I think it changed around the 60s, late 60s, where they would automatically, as soon as you put in a new put in a new address form, they would send you a new call sign.
But doesn't your call sign, I mean, maybe I missed this part, I probably did. Doesn't it denote what state you're from, like Oregon or Jersey or Maryland?
Loosely, because like we have a 9 call in our club here. We have a couple of 3 calls and a couple of 4 calls in our club in Oregon. So
okay.
you can, it used to be that you could not even apply for a call sign out of your area, but now you can.
Ah, okay.
So long as it's not Guam, Hawaii, Alaska.
Yeah. Oh, outside the continental.
Scott, one question.
Yep.
You talk about the phonemic, how you would use a word instead of a letter. Is there a list that I could, where can I find that list?
The ITU phonetic alphabet?
Is there a list?
Yeah, just look up ITU phonetic.
ITU?
Yep, International Telecommunications Union. Here, let me close that.
It's also shown on the bottom of the band plan for the United States for ICOM. That was in the package.
Oh, thank you.
Here.
Great. ITU. Phonetic alphabet. Thank you.
NATO phonetic alphabet. Let's see. Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, Hotel.
Better start memorizing that.
Actually, as soon as you get on the air, you're going to use it all the time. Because you'll find that, like, if you check into a net, they require you to do phonetics. Right. And you're going to want to do it anyway.
Thank you for that.
I think there was one question on the ham radio online, whatever it was, that free one that you sent us, that said that you shouldn't be using phonetic alphabets. I don't. Should not. Yeah,
Oh,
I remember that.
Yeah, of course.
It says it's encouraged.
It's encouraged.
Encouraged. Okay, that's right.
Yeah.
Okay, thank you.
Yeah, you should definitely be using phonetics, especially if conditions are anything. If it's somebody who you don't know, and or somebody who, like, you're giving you're giving your call sign and calling CQ. The problem with a lot of letters is that if the conditions are noisy, they all sound the same.
Yeah, it's true.
So
the other thing is, if you're speaking somebody of Latino descent, some certain letters, when they're said versus phonetically, have similar sound, like the J and the H.
Yeah, and try dealing that with Japan.
Oh wow.
Yeah. I was in Vanuatu a year ago, and we worked thousands of Japanese stations, and a lot of them on phone, and you really need the phonetics.
Wow.
So
I guess English is the international language with ham radio.
Yeah, it is.
Okay.
All right. Any other questions? If you're signed up for an exam, go kick its butt. We'll see you at 2:00. That's my next stop.
Scott, thanks a lot, man. You're awesome.
Yes, thank you.
I'm glad.
Thank you for everything, Scott. Appreciate you.
Thanks a lot.
So yeah, keep me up to date if you're not taking an exam today. Keep me up to date as to how things are going, and don't let it slide.
No, I'm not, and I got to get the momentum and keep it going. I agree.
Thanks, Scott.
I find the app being a very handy tool, so I'm definitely going to be utilizing this app for the next week until I build up that 85% or higher.
Yep.
And then I'll be shooting you an email to do the test.
Okay.
Quick question though. My setup at home in my office, I have 3 monitors. Is that going to be an issue if I do?
They'll just look around the room, and they'll probably tell you to turn off 2 of them or something.
Okay, sounds good.
Scott, one more thing.
One more thing.
On my phone, I have unknown callers.
Don't forget to take your background and unfuzz it.
Oh yeah, I will. On my phone, I have silence unknown callers, and I'm trying to find it in my settings, because if you call,
what's your number? Oh wait, I have your number. Unless you want.
Yeah, my number. Okay.
What you can, if nobody else, if you don't mind giving it, I'll just call it right now.
Oh yeah, it's 510-657-6458.
Everybody call her right now.
Everyone call her right now.
Talk about driving her nuts. No,
do you
My
have
husband
an
does.
do you have an Android or a iPhone?
I have an iPhone and I went through my settings, but I can't seem
If
to
it was
find
an
it.
Android, I
It
could help
says
you,
it's been
but since it's
forwarded to a
iPhone,
voice
I can't.
messaging system.
Oh, did it go forward? Okay, I'll find it in my settings and disconnect that part.
Okay.
Now,
All right.
another thing we can do with Android is enter it into our friends list. That will
Contacts list.
go through.
True.
Okay.
So if you put my number,
Now bypass that.
Oh wait,
yeah.
because I can send you a text.
Yeah, I was just gonna say send a text message and you could just add to your contacts. As
Oh, I
long as
will.
they're in
Okay.
your contacts, you'll be able to get the
Here.
call.
I just
That's-
sent you a text.
Bye. Thank you.
Thanks, Peyton. How'd you do? How you feeling?
Good.
Good. When are you taking a test?
I'm planning on studying a little bit more on myself and getting super confident, then pretty confident, and then going from there.
Very cool.
I think it's
Thank
very
you.
cool to see young people doing this. So
Yeah,
good job.
isn't it?
Yeah, it's awesome. I think it's great.
Scott,
Bye.
what was the app that Miss Ayel and others have referenced? What app was that?
Ham Radio Exam Tech
Thank you.
by Roy Watson.
Thanks very much.
It's Scott. This is Vladimir. Could you move my time an hour or two? I have to go to a meeting right now, so won't be able to take it right away.
Okay.
But, like I said.
I'll just take you off the early calls. You'll get called.
Okay.
sometime.
Thank you, sir.
All right.
Okay.
Cool.
Appreciate it. Thank you.
All right. I'm gonna go and kick back and grab something to eat and drink before I go.
Sue,
give it
Sue, don't hang up.
Scott.
I
one
can
question.
leave the message. I can leave the class open.
Yeah.
Oh,
Thanks,
okay.
Scott. I'm taking off. Thank you.
Sue, I want to tell you, go into settings on your phone.
Okay.
Scroll down to where it says phone, not cellular. And the silence unknown callers is near the bottom.
Okay, hang on.